Hello everyone, welcome to the BYJU'S Exam Prep, and this is the Digital Electronics Part 3. We already committed that the remaining portion we are going to cover into the Part 3. So guys, whatever we have committed to you, now it's time to fulfill the commitment. And so everyone, welcome to the session. And one thing more, everyone, if everything is fine, audio and video, please inform into the comment box, write into the comment box. Everything is fine so that we can quickly start the session, right? What topic we are going to cover? Maybe the people will think, sir, what topic we are going to cover in the today's session? So let me discuss about those topic also. Which topic we are going to cover, right? Yes, Rahul, ADC as well as the DAC, both are basically important for the gate as well as for the ESC also, for the electrical as well as the electronics. So whatever the topic today we are going to cover now, this is important for the all of the branches, right? Okay. So good afternoon, Ishika, Vignesh, Bhargavi, RK Charan, Srinivas, Rahul, Raminder, right, Amita, Rahul, Ellen, everyone, and quickly join the session. Pujita, Ashok. One thing more, which topic we are going to cover in the today's session, guys? So let me write that important topic also, which we are going to cover in the today's session. So guys, in the today's session we are going to cover the one ADC, analog to digital converter. Second one is called DAC, digital to analog converter. ADC and DAC we are going to cover the session. Apart from this, the third one we are going to cover in this particular session is regarding to the finite state machine. Already the lots of people have discussed sir, whether the FSM is important or not. So guys, every year one question is coming from the FSM. So definitely we are going to cover the FSM also. Shubham, Preeti, Ellen. Ellen, this session is going to be happen around 2.5 hours, right? So FSM, and just after the FSM, right, we are going to cover the delay. Delay means what? Delay into the sequential circuit, that is regarding to the setup time, hold time, setup time, hold time, contamination delay, and maximum clock frequency. These four topic we are going to cover in this particular session, right? So everyone, welcome back. Welcome to, sir, aap Udaipur aa gaye? Returned? Yes, Sagar. Now I am in Udaipur, Rajasthan. Babaji, yes, Samir. So let's start, guys, with the 60 people are there. Karma बढ़ता रहेगा, लोग जुड़ते रहेंगे. So directly we are starting the session, guys, quickly. First, everyone try to understand in the DAC or the ADC, with a very famous question they will ask about the resolution. Sir, what should be the meaning of resolution? So everyone try to understand. Resolution means corresponding to the 1 bit change into the digital. If you go into the digital 1 bit, right, in the successive bit, then how much analog voltage is going to be changed is called nothing, it is just a resolution. यानी आप अगर डिजिटल के सक्सेसिव नंबर्स पे अगर जाते हो तो रेजोल्यूशन में कितना चेंज होता है और एनालॉग इनपुट में कितना चेंज होता है, दैट इज कॉल्ड नथिंग, इट इज जस्ट ए रेजोल्यूशन, राइट? Utkarsh, the Hamming code will cover into the communication. This is a digital electronic session. And yes, RK Charan, this session is useful for the EC, E, and instrumentation branch. All the branches, this session is very, very important, right? Already in the electrical also, last year, one question came directly from the FSM, right? Or A to D, D2 also question they are frequently asking. So everyone try to understand. Suppose I am saying that if 0001 is represented by 1 volt and 0010 is represented by 1.25 volt, so we can say that in the digital we are moving into the successive numbers. Then we can say that how much analog voltage is change. Such change in analog voltage is 0.25, and that 0.25 volt itself is called nothing, it is just a resolution. So whenever, sir, ADC, yeah, one more time I want to repeat, everyone. ADC, DAC, FSM, setup time and hold time, these are the important topic for the EC as well as for the EE student. So now people who are from the EE electrical background also must attend the session because it is a very, very important, right? CO will take Rajani, CO will take the separately, no issues for that. Many complex circuit being asked in the gate exam. Uday, I will cover those portion also, no issues. Memory, if you will take the time, then Utkarsh, I will cover the memory also. पहले मैं क्या बोल चुका हूं उस पे ध्यान दो और उसको focus करो, right? Okay. So whenever they will ask about the resolution, guys, always you have to follow always for the resolution you have to follow कि reference voltage upon 2 raised to power n minus 1, where the VR is called reference voltage, n is called number of bits, whether it is a ADC or it is a DAC, whatever in the question they will ask. If they are asking about the resolution, always you have to understand the formula VR upon 2 raised to power n minus 1. One thing more, this session is not only for the theoretical session. In this particular session, guys, we are going to cover the theory as well as the question also. Or lots of question we are going to cover. Around 20 question for the ADC and DAC, all right, we are going to cover in this particular session, right? Right, okay, now one thing more before going to start now. So one thing more, people may confused with the reference voltage and the full scale voltage. Everyone try to understand. There will be the one word that is called full scale voltage, that is approximately equal to reference voltage VR. But maybe if you want to correlate it now, we can say that the VFS is called nothing, it is just a 2 raised to power n upon 2 raised to power n minus 1 into VR. ये क्या हुआ? 2 raised to power n upon 2 raised to power n minus 1 into VR. This is a general formula. Otherwise you can feel for the larger value of n, VR and VFS are always equal. One thing more, guys, VFS means itself is called full scale voltage. VFS means what? Full scale voltage. And VR is called nothing, it is just a reference voltage. Raya, Raj Pandey, Sonali, right, Venu, a very good afternoon everyone. And please inform to all of your friends also, and people who haven't liked this session, like it also, right? Okay. Now there will be the one thing more, guys, the percentage resolution. Whenever they will ask the question regarding to the percentage resolution, always you have to remember कि resolution upon VFS into 100, that is called percentage resolution formula. Already we know that the resolution formula is called nothing, it is just a VR upon 2 raised to power n minus 1 upon VFS into 100. Already we know that VR and VFS are basically approximately equal. So we can say that this is called nothing, it is just a 2 raised to power n minus 1 into 100. This is called percentage resolution. So percentage resolution mainly depends upon the number of bits only. Right, it will depends upon the number of bits only. One thing more, Anju, a very good afternoon beta, good morning beta. Okay, one thing more, apart from this there will be the one more formula is there, guys, which is essentially required to understand. Ki sir, if the percentage, if they will ask about the percentage accuracy, always you have to remember ki error upon VFS into 100, this will give you nothing, it is just a percentage accuracy. Maybe they will ask the questions regarding to percentage accuracy also. You have to use this formula. You have to use this formula, that is error upon VFS into 100 itself is called nothing, it is just a percentage accuracy, right? Okay. Apart from this, everyone try to understand whatever the resolution is there. Sometimes resolution is also referred as what? The step size. Sometimes resolution is also referred as the step size, right? So do not conscious regarding to this, do not be focused regarding to the resolution and step size itself is called nothing, it is just a 1. Itself is basically nothing, it is just a equal. Okay, apart from this, there will be the one thing more. Whenever they will ask about the quantization, everyone, whenever they will ask about the quantization error, always you have to focus कि minimum everyone sampled value minus quantized value. कुछ value दे रहा हूँ, formula दे रहा हूँ, there direct question we can say that direct the question based on those formula also we can expect. And guys, among us we have a great faculty, that is the Sanjay Rathi sir. So everyone, warm welcome to the Sanjay Rathi sir in this particular session. Everyone. And Sanjay Rathi sir is also going to cover the remaining portion of the analog like MOS and BJT, right? So sampled value minus quantized value is called quantization error. And whenever the people will ask about the quantization error, maximum quantization error, that is called nothing, it is just a step size, that is called resolution, right? Step size divide by 2. And whenever the question they will ask about the quantization error power, mean square value itself is called nothing, it is just a power, right? So mean square value itself is called power. So whenever they will ask about the power, always you have to write the step size square divided by 12. So I have given the few formula. Based on formula we can directly expect the question. Yes, Ayan, right? Okay. So again, everyone just give me the idea about what we have understand up to this portion. Ki sir, resolution, if they will ask about the resolution, this is called VR upon 2 raised to power n minus 1. This is resolution. Whenever they will ask about the percentage resolution, 1 upon 2 raised to power n minus 1 into 100 is called percentage resolution. Whenever they will ask about the percentage accuracy, error upon VFS into 100 is called percentage accuracy. Resolution and step size is equal. And whenever they will ask about the quantization error, sampled value minus quantized value is called quantization error. Maximum quantization error is called step size divided by 2. And quantization noise power, this is called quantization error power. Quantization error power. Whenever they will ask about the quantization error power, we have to write step size ka whole square divided by 12. That's what we can say that. Get student right. Right, okay. Hello Mayur, how are you? One thing more guys, before going to start the next session, next topic, let me discuss one thing more. Whenever they will give you the DAC means what? Digital to analog converter. Whenever they will give you the DAC guys, always you have to remember input is what? Digital, and output is called nothing, it is just a analog. Digital and the output is called nothing, it is just a analog. So this is called digital input and this is called nothing, it is just a analog output. Always you have to remember the one word, sir, the communication and the digital PDF. Communication, I will take the part 3 also, Adrila, Surya, and all the part 1, part 2 and part 3 grouped together I will send it. So the complete communication PDF you will get, right? And this PDF, digital electrons PDF, just after the completion of session, you will get into the Telegram channel. I will share the link of the Telegram channel also. Guys, I have shared already the link of the Telegram channel. If you haven't subscribed the channel, join this channel because every class PDF you will get in this channel only, right? Okay. Now everyone try to understand. Ki whenever in the DAC is given and you have to find out the analog output, always you have to consider the one thing that is called resolution into decimal equivalent into gain. Always you have to find out ki whenever the DAC is given, you have to, whatever the input, digital input is given, convert this digital input into the decimal equivalent, multiply with the resolution and the gain. By default in the question, if the gain is not mentioned, then always by default if the gain is not mentioned, you have to use as a 1. Sir, how I'm not getting it? No issues. Let me give you the one example guys. Let me give you the one example. Suppose I'm giving you, this is called DAC. 4-bit DAC is given and I'm writing the resolution is called nothing, it is just a 0.5. Suppose I'm giving you the resolution is called, sir, आप digital कब से start किए थे? I am late. Around 12 o'clock, 15 minutes late, no issues, right? So suppose I'm writing this is called 1, or suppose I'm writing this is called 1, this is 0, this is 1, this is 0. This one is MSV and this one is LSV. Resolution is 0.5 and gain is called nothing. If it is not mentioned, by default we have to consider the gain as a nothing, it is just a 1, right? Now if you want to find out the analog output guys for this DAC, you have to remember, sir, what should be the decimal equivalent of this? So decimal equivalent of this one is called nothing, it is just a, this value is 1010, and if you want to write into the decimal equivalent, it is called 10. So analog output is called nothing, it is just a resolution, that is 0.5 into decimal equivalent is into 10, and gain is not mentioned, so by default we are taking the gain as a nothing, it is just a 1. So this is called nothing, it is just a 5 volt. So always you have to consider कि whenever the DAC is basically given and the resolution of the DAC is given, decimal equivalent into resolution into gain itself is called nothing, it is just a output of DAC. You have to remember this point. Alright, Monisha, it's not 2.5, it's 5 only, right? Okay. Okay. Now everyone, now we are moving into the next. We are going to discuss the 4 type of DAC. Everyone, 4 type of ADC we are going to discuss. The first one is called counter type ADC. Counter type ADC. Second one we have to discuss about the successive approximation register type ADC. And whatever the question will ask into the final exam, don't worry. You guys are, after the attending this session, you guys are going to solve each and every questions regarding to that. Setup and whole time, I will take very serious manner and I will give you the 2 formula. With the help of those 2 formula, you are able to solve each and every question regarding to the setup time and whole time, right? And in the last I will take, so you should be very, very conscious regarding to this. And the third one we can say that counter type ADC. The second one is called SAR, successive approximation register type ADC. Third one is called I will take flash type ADC. And the fourth one is called dual slope ADC. Dual slope ADC, right? So these 4 type of ADC we are going to cover, right? And after that DAC 2 type of DAC we are going to cover, weighted register type or R2R type. First everyone try to understand. First we are going to discuss about the counter type ADC. In the counter type ADC guys, this is called nothing, it is just a comparator. Here whatever the value, this is called positive terminal, this is called negative terminal. Whatever the value is there, I can write this is called VP. Whatever the value is there, we can say that it is called VN. So this one is called VP and this is called VN. A moderator, if the moderator is live, please remove this unwanted chat. Right? VP and VN, right? Everyone. This is called VP and VN. Now if you want to discuss about the VP and VN, right? Here the feedback voltage is called nothing, it is just a VF. Now this VP and VF is basically compared. So now if VF and VP is compared, if VF is greater than, or this is analog input, that is called VA. If VF is greater than or equal to VA, the output of the comparator will nothing, it is just a 0. And if VF is less than VA, means VA is greater than VF, then output of the comparator is called nothing, it is just a 1. We are just assuming. Right, okay. Okay, कोई moderator नहीं है. Okay, so let me do it. Okay, now, so this is the comparator only, they are going to compare these 2 values, and if the positive terminal value is greater than negative terminal value, you will get 1. If negative terminal value is greater than the positive terminal value or equal to also, the output is going to be 0. Now what should be the meaning of this AND gate? Guys, for this particular AND gate, if you want to discuss, suppose the comparator will provide the 1. We want to convert this 1 as a clock. And that's why we are using the AND gate. In the AND gate, the 1 input is called nothing, it is just like this. And suppose a high voltage is like this. So whenever you will do the ANDing with this, only you will get this type of signal into the output. And this type of signal you will get into the output, the meaning itself is called the up counter will increase the up counter receive the 1 clock, and whenever the up counter receive the clock, the counter will increase their 1 state, right? So this is just it means there will be the no, you can say that extra role for this AND gate. AND gate having the only one role, कि whenever here it is a 1, that 1 should be converted in the form of clock and it will apply to the up counter. That's why we are using this AND gate. And what happens if the 0 is there? Then directly you will get the 0 and there will be the no clock is applied to the up counter. Now, up counter initially having the state 0 0. This is a 4-bit up counter we are discussing, right? 0 0 0. And this is called nothing, it is just a digital to analog converter. And let for the example I am taking the resolution of this is called nothing, it is just a 1. Just I am taking the example so that you can understand how this circuit is going to be work. Now, whatever the input is there, we have to convert this one into the decimal equivalent multiplied with the resolution and you will get the VF. Now this VF and VA is going to be compared. Now this VF and VA is going to be compared. And if VA is greater than VF, you will get 1. If VF is greater than VA, you will get the 0. Like that type of circuit is going to be happen. Now how it will be happen, everyone? No, Rahul, I will explain those points. Setup time, hold time, contamination delay, critical path delay, the frequency, maximum clock frequency, everything will cover in the today's session only, right? Okay. Now everyone try to understand. First VA and VF, suppose I'm saying that when the clock is basically not applied, all the flip-flops of the up counter are basically nothing, it is just a reset condition. So output is 0, 0, 0. Now how the circuit will work? Suppose I am applying, it is called nothing, it is just a 0.7 volt. How the conversion is going to be happen? So everyone try to understand. 0, 0, 0, 0, 0, right? So decimal equivalent of this one is called nothing, it is just a 0. 0 into 1, that is called 0. So here you will get the 0 volt. Gain I am just taking as a 1. It means the DAC will provide the output, analog output, just like decimal equivalent of the input into resolution will give you the output. Yes, definitely RK Charan, definitely. This is called 0 volt. 0 volt and 0.7 volt is compared. Which one is greater? So 0.7 volt is greater. So if 0.7 volt is greater, then you will get the 1. Now if you will get the 1, already we know that the AND gate having the role that 1 will be converted as a clock. And now the up counter receive the clock. So this is the first clock the up counter will receive. And whenever the up counter will receive the clock, it is going to increase their state. So whenever you will apply the clock, it is going to increase their particular state. And here it will become nothing, it is just a 1. It's a simple up counter. If you apply the clock, it is going to increase the state. If there will be the no clock, it will retain on the same previous state. Now 0, 0, 0, 1 having the decimal equivalent. Sir, having the decimal equivalent 1. 1 into 1, sir, you will get the 1. So here now you are getting 1 volt. Now this 1 volt and 0.7 volt is compared. Which one is greater? So definitely the 1 volt is greater. So here you will get 0. Here you will get the 0. So the AND gate provide the output also 0. If AND gate having the output 0, it means up counter does not receive any clock. And if up counter does not receive any clock, so up counter has to maintain on this state. So 0.7 volt having the conversion digital equivalent is 0001. Again, everyone don't worry about or don't think ki 1 is converted like this, 2 is converted like 0010. It's not a binary. We are not writing into the binary. We are converting into the pattern of the digital, that is 0 and 1 form. Right? So people who are thinking, sir, yes, 0.77, so we are writing as a 1. No, it's not 1. It's a 0001. Right? Are you getting my point? It's we do not have to require to convert into the decimal. For this one, we have to convert it, but direct output, if you want to write the DAC, now this is called 0001. So how many clock we have applied? Sir, we have applied the 1 clock. And the 1 clock, the conversion has been happened. Now suppose we are changing the state. Now suppose we are applying the VA is not nothing, it is just a 1.4 volt. How the conversion is going to be happen? So everyone, initially all the flip-flops are basically reset condition. Without applying the clock, all the flip-flops are basically reset condition. So 0, 0, 0, 0. 0, 0, 0 having the decimal equivalent, sir, 0 only. 0 into 1, sir, again we will get the 0. So VF, you will get the 0 volt. Now this 0 volt and 1.4 volt is compared. Which one is greater? So definitely positive terminal voltage is greater than the negative terminal voltage. So definitely you will get nothing, it is just a 1. What should be the role of AND gate? Sir, AND gate will convert this 1 into the form of clock. So here you will get nothing, it is just a clock. Now up counter receive the clock. So up counter will, whenever the up counter receive the clock, it is going to increase their state. So it is going to increase their state and it will become nothing, it is just a 1. Now if it will become 1, so 0001, what should be the decimal equivalent? How many clock we have applied? The first clock. 0001 having the decimal equivalent, sir, 1 only. 1 into 1, sir, 1. So now here you will get nothing, it is just a 1 volt. Now this 1 volt and 1.4 volt is compared. Which one is greater? Sir, 1.4 volt is greater than 1. If 1.4 volt is greater than 1, so what you will get, sir? Positive terminal voltage is negative, greater than the negative voltage terminal, right? So you will get it is what? 1. Now here if you will get the 1, that 1 will be converted as a clock. Now if the 1 is basically converted as a clock, means up counter received the clock. And if how many clocks we have received? So this is the second clock. If this is the second clock, now up counter will increase the state and it will become 0010. It's a simple up counter, nothing more than that. Now, sir, what should be the decimal? We have applied the 2 clock, 0010, having the decimal equivalents at 2. 2 into 1, you will get 2 volts. So here you will get the 2 volt. 2 volt and 1.24 volt is compared. Which one is greater? So 2 volt is greater than 1.4 volt. Means negative terminal voltage is greater than positive terminal voltage. So definitely we are getting the 0. If you will get the 0, here you will get the 0. And here you will get the 0, so up counter will retain on this state only. So whenever the people will ask, sir, what should be the digital output of 1.4 volt corresponding to resolution of 1 this? It is called 0010. That's what we can say that. Now everyone, now if you understood this one, so we can feel, sir, for the 0.7 volt, 1 clock is applied. For 1.4 volt, 2 clock is applied. If you apply 2.3 volt, 3 clock is applied. Right? So everyone try to understand. Here we can make a statement that whenever the analog input increases, the conversion time is also going to be increased. Whenever the analog input increases, the conversion time is also increased, and that's why this type of count ADC is also called stair type ADC or dual slow or state type ADC or ramp type ADC. It means whenever in this question, if you want to discuss about the minimum conversion time, that is called 1 clock. If you want to discuss what should be the maximum conversion time, sir, it will depends upon the what number of bits. If it is a n bit are there, then we can say that it is called 2 raised to power n minus 1 t clock, because when it will goes to the 111 means what, 15. So it will goes to the 15 value, it is going to be stopped. This is the maximum limit. So this is the maximum conversion time. And if you want to find out the average, 2.5 hour, Nitesh, average conversion time. This is called nothing, it is just a minimum plus maximum divided by 2. So 1 clock plus 2 raised to power n minus 1 clock divided by 2. So 1 cancel out, 2 raised to power n divided by 2. This will give you nothing, it is just a 2 raised to power n minus 1 t clock. This is called average conversion time. So again, everyone try to understand. In this question, in this type of counter, only 2 type of question we can expect. Right, 2 type of question we can expect. The first one, sir, first one we can say that what should be the minimum conversion time, what should be the maximum conversion time, what should be the average conversion time. This is the first type of question we can expect. Second type of question we can expect regarding to this one is, sir, if analog input is given, then what should be the decimal or what should be the digital equivalent? So guys, everyone try to understand. If you want to discuss about the digital output, you have to remember analog input, and after that we'll discuss the question also, right? Analog input divided by resolution. Now whatever the value you are getting, you have to write into the integer value, in the integer form, and actually the next integer form. Next integer form means 1.23 you will get, so you have to write into the 2. 2.9 you will get, you have to write into the 3. 1.01 you will get, you have to write into the 2. So that's why I'm writing. And if 1 is only integer value you will get, you have to write the same as integer value. Right? Okay. So we can next integer value, and whatever the value we are getting, this integer, convert into the binary. Convert into the binary, you will get the answer. Convert into the binary, you will get the answer. Very simple. Suppose I'm giving you one question. Resolution is called 0.5 volt. Analog input is applied is called 3.7 volt. And I'm asking what should be the digital output. What should be the digital output for 4-bit counting type ADC? How we are going to do it? So everyone, if you want to solve this question, I will give you the direct question also, right? I have taken already lots of questions, but I am giving you here the idea. Sir, first what should be the VA? VA is called VA upon R, we have to write. So VA is called 3.7, resolution is called 0.5. So this will give you nothing, it is just a 7.2 volt. Sorry, 7.4 volt. Now we have to write into the equivalent or next integer value, that is called 8. And corresponding to 8 into the 4-bit binary number is 100. So this is your answer. So this is your answer, right? Yes, Pujita, Shubham, Arun, Narendra Prasad, Kaja, Preeti, everyone responded correctly. बहुत बढ़िया, Bhargavi. Now, so this is a very slow, right? This is also called what? RAM type ADC or staircase type. It is a slower ADC, right? Slowest, or we can say that the slower ADC. We want a ADC in which the conversion time is basically independent of the analog input. Here we know that the conversion time, if you apply the smaller value, the conversion time will be small. If you apply the larger analog input, then conversion time is basically large. More clock is basically required to convert it. So we required a circuit in which the conversion time is basically fixed. And that's what basically second type is called. Nothing, it is just a what? Successive approximation register type. SAR type ADC. Here the conversion time is always fixed. The resolution. DAC, the resolution basically based on the DAC only. Right? Here, Utkarsh. Now everyone try to understand. Now instead of here we can say that now we are going to discuss about the successive approximation register type. Here we can say that in the SAR type ADC, the conversion time is independent of the analog input. Conversion time is independent of the analog input. Whatever the analog input is, the conversion time is always fixed in the SAR type. How? Everyone. Again, we can say that this is called analog input and this is called your feedback voltage. The role of the comparator is something you can feel. This is the same circuit you can feel, right? This is the same circuit. Only there are two changes happened. One, instead of AND gate, we have used the control circuit. And instead of normal binary counter, we have used the ring counter. So hope you guys understand about the ring counter. Let me discuss about the ring counter first. How much bits are basically ring counters? So 4-bit ring counter we are considering, right? Nitesh, I have already given ना, the conversion time is basically slow here. नितेश मेरी बात ही नहीं सुनते हो आप तो बेटा. मैंने पहले ही तो बोला कि यहां पर कन्वर्जन टाइम जो था ना वो एनालॉग इनपुट के ऊपर डिपेंड करता था. एनालॉग इनपुट जैसे जैसे बढ़ाते जाओगे कन्वर्जन टाइम भी बढ़ता जाएगा. हमको ऐसा सर्किट चाहिए जिसमें कन्वर्जन टाइम फिक्स्ड हो, राइट? और उस कन्वर्जन टाइम फिक्स्ड के लिए हमने नया बनाया, दैट इज कॉल्ड एसएआर टाइप. आई हैव ऑलरेडी रिपीटेड दिस स्टेटमेंट नितेश मेरे भाई, राइट? ओके. So ring counter, let me discuss about the ring counter. Ring counter having the state 1. If the first clock is applied, this is the state. Right? Now when the second clock is applied, this is the state. Now when the third clock is applied, this is the state. And now when the fourth clock is applied, this one is the state. So already know that in the n-bit ring counter, the modulus is called nothing, it is just a n. Ring counter is nothing. MSB having the 1, and after that, that 1 will be shifted among all the flip-flops. That's what it is called, ring counter, right? Okay. Now everyone try to understand. So ring counter, we know that. What should be the role of the control circuit here? So guys, in the control circuit input, there will be the two possibilities. Suppose after the first clock, we are in this particular position, 1000. And now, if you'll apply the second clock, then what should happen to the ring counter? So ring counter will make this next bit 0 to the 1 and the previous one to the 0. That's what basically the role of the ring counter. But whether it is going to previous one is going to be hold and it will be directly shifted, it will depends upon the input of the control circuit. If the input of the control circuit is 0, then control circuit will say to the ring counter, do whatever you want. I will never change your state. I will not change your state. Then ring counter will directly make this 0 to 1 and this 1 to 0. They are not going to change any. It means in the state of the ring counter, they are no going to, or there will be the no changes going to be happen when the control circuit having the input 0. But what happened guys, when the control circuit having the input 1? Now the control circuit having the input 1, then control circuit will say to the ring counter what actually you want to do. Ring counter will say I want to make this 0 to 1 and I want this 1 to 0. But as we know, the control circuit having the input 1, so the control circuit will say to the ring counter, I will not let you make this 0. I have to hold it. Why this is holding the previous one? Because the control circuit having the input 1. कहने का मतलब इतना है, अगर कंट्रोल सर्किट के इनपुट में 0 है तो कंट्रोल सर्किट रिंग काउंटर को बोलता है कि जा सिमरन जा, जी ले अपनी जिंदगी। वो उसके स्टेट में कोई भी चेंज नहीं करता है। पर वेन एवर द कंट्रोल सर्किट हैविंग द इनपुट 1, वो रिंग काउंटर का नेचर है कि दे आर गोइंग टू चेंज द नेक्स्ट वन 0 to 1, but the whether the previous one is going to be hold or not, it will be decided by the control circuit. If the control circuit having the input 1, it is going to hold the previous state. That's what the basically nature of the that is called SAR type, right? Control circuit, and it may happen with the every right any place, no issues for that, right? Okay, now how the operation is going to be happen. So everyone try to understand how the operation is going to be happen. So if you want to discuss about the operation, guys, let me discuss the one example I am taking. Suppose here I am writing the 0.7 volt, and let me discuss how this circuit is going to be operated. Right. Okay, now everyone, thank you Shikla, thank you. Okay, now everyone try to understand how the operation is going to be happen. Everyone, suppose initially, and there will be the one thing more, guys, there are one SOC, start off conversion. Start off conversion is the signal which is provided by the user, right? If you apply the signal here, you can apply the user here, that is called SOC. Then only the ring counter is going to be operated, or then only the circuit is going to perform their task. So SOC means nothing, it is just a start off conversion. And whenever the entire conversion is going to be happen, then we can say that then this ring counter will send a signal to the user, that is like EOC, end of conversion, ki whatever the task you have assigned to me, I have completed that task, right? Okay. And for the ring counter, they are not taking the clock from here like the previous condition. They have a separate arrangement for the clock, guys. हाँ कंज्यूमर ये चतुर है पर उसको क्या पता कि यहाँ इतिहास रचा जा रहा है. Okay, now so guys, first if you'll apply the ESOC, start of conversion, press the button, and now if you'll apply the first clock, the state will become 100. It means if you want to discuss how this circuit is going to be work, everyone, if you'll apply the 0.7 volt, how the conversion is going to be happen. So everyone try to understand. And here the resolution we are taking as a 1, right? Okay. Vimla, this was also happened very soon, right? Maybe day after tomorrow, right? But first focus on the digital electronics now. Now, it means when the first clock is applied, first we have to apply start off conversion, SOC, and then if you'll apply the first clock, then the first start of conversion we have applied, and then we have to apply the first clock, the state will become nothing, it is just a 100. Now after the 100, what should be the decimal equivalent of this? So decimal equivalent of this one is called nothing, it is just a 8. So 8 into 1, sir, we will get the 8. So here you will get the 8 volt, because the DAC is called nothing, resolution into decimal, right? Resolution into decimal equivalent is called output of the DAC. So DAC output is called nothing, it is just a 8 volt. Now this 8 volt and 0.7 volt is compared. Which one is greater? So definitely this 8 volt is greater. So the analog input of VF, or we can say that the voltage connected to the negative terminal is greater than the voltage connected to the positive terminal. So this comparator will provide the 0. Now if this comparator will provide the 0, the control circuit having input 0. Now if the control circuit having input 0, then control circuit will say to the ring counter, "Ki do whatever you want. I will not change any state for you," right? Control circuit will say to the ring counter, "जा सिमरन जा, जी ले अपनी जिंदगी." सिमरन बोलती है कि जी तो लूंगा अपनी जिंदगी, पहले क्लॉक दो. So whenever you will apply the second clock, it will make this 0 to 1 and this 1 to 0. This one is not going to be hold. Why? Because the control circuit having input 0. That previous one is going to be hold only when the control circuit having the input 1. Right? Okay, ji. Now, so after this, the state will become nothing. It is just a 0, 1, 0, 0. Now control circuit. Now, what should be the decimal equivalent? This is the second clock we have applied, right? What should be the decimal equivalent? So this is the decimal equivalent is 4. 4 into 1, if you will compare, that will give you 4 volt. Now 4 volt and 0.7 volt is compared. Which one is greater? So negative terminal voltage is greater than positive terminal voltage. So negative terminal voltage is greater than positive terminal, definitely you will get 0. Here you will get the 0. So control circuit again will say to the ring counter, जा सिमरन जी ले अपनी जिंदगी. Now the सिमरन बोल रही है, अरे जी तो लूंगी जिंदगी, clock तो दो, let me give the clock. Now if you apply the clock, then what is happened? Then ring counter, this is the third clock we have applied. This will make the next one to the next bit to the 1 and the previous bit to the 0. It means after the third clock, your state will become 0, 1, 0. Now, what should be the 0? This is after the third clock, we can say that. What should be the 0, 0, 1, 0 having the decimal equivalent? So 0, 0, 1, 0 having the decimal equivalent is called nothing, it is just a 2. 2 into 1, you will get 2 volt. Now 2 volt and 0.7 volt is compared. Which one is greater? So definitely negative voltage terminal is greater than the positive voltage terminal. So you will get nothing, it is just a 0. Now again in the control circuit having the input 0. So control circuit will say to the ring counter, do whatever you want. And control circuit ring counter will say, give me the clock. And now if you apply the clock, it will become 0. So after applying the clock, the state will become 0, 0, 0, 1. And when the last bit will become 1, LSB will become 1. Immediately the ring counter will send a EO signal to the EOC signal to the what? User. Ki whatever the task you have given to me, I have completed that task. And that's what we can say that how much conversion time is basically there. First clock, second clock, third clock, fourth clock. If do not consider the SOC and EOC as a clock, then we can say that the 4 clock is basically required to convert it. If we are not, again, I am repeating, if we are not considering the SOC and EOC for the clock, then we can say that first clock, this state, second clock, this state, third clock, this state, and fourth clock. So 0.7 volt is converted as a digital output 0001 by the SAR type into the 4 clock. Apart from this, 2 other additional circuit is or additional signals are there. One is SOC and the one is called EOC. Right? Okay, ji. Again, people having the doubt, sir, I am not understanding it. No issues. Let me give you the one example. One more example, everyone. Let me give you the one more example so that the more clarity will take place. Right? Okay. Suppose I am writing this is called 7.9 volt. How the conversion is going to be happen? Everyone try to understand. Yes, Preeti, definitely required, but I am just giving you, in the last I will write it, the formula also I will give you. First, let me explain how the circuit is going to be operated. Now, everyone try to understand. Suppose, now, if you will apply the first SOC signal, katak, SOC signal, start of conversion. Now, if you will apply first clock, even if you will apply the first clock, the state will become nothing, it is just like this. 1, 0, 0, 0. What should be the decimal equivalent of this? Sir, 1, 0, 0 having the decimal equivalent is called nothing, it is just a 8. 8 into 1, you will get 8 volt. You will get 8 volt. 8 volt and 7.9 volt is compared. Which one is greater? So definitely negative terminal voltage is greater than the positive terminal voltage. So we will get 0. If we will get the 0, control circuit having the input 0, then control circuit will say to the ring counter, do whatever you want. Ring counter will say, give me the clock, second clock. And if you will give me the second clock, I will make this 0 to 1 and this 1 to 0. Ring counter, this control circuit will not change this state because the control circuit having the input 0. So the control circuit will say to the ring counter, do whatever you want. This one is the simple state of the ring counter. After the second clock. Now what should be the decimal equivalent? So decimal equivalent is 4. 4 into 1, 4. So now you will get nothing, it is just a 4 volt. Now this 4 volt and 7.9 volt is compared. Which one is greater? So 7.9 is greater. If 7.9 is greater, so positive terminal voltage is greater than negative terminal voltage, so definitely you will get the 1. If you will get the 1, then control circuit having the input 1. Now if the control circuit having the input 1, then control circuit will say to the ring counter what actually you want. Then control circuit will say to the ring counter, I want this 0 to 1 and I want this 1 to 0. But as we know, the control circuit having the input 1. So control circuit will say to the ring counter, I will not let you make it 0. I have to hold it. Why I have to hold the previous one? Because I have a 1 into the input. Now this is going to be hold. So after the third clock, after the third clock, the state will become 0110. Now 0110, what should be the decimal equivalent? Sir, 6. 6 into 1, sir, 6. So now here you will get the 6 volt. Now this 6 volt and 7.9 volt is compared. Which one is greater? So definitely 7.9 volt is greater. So positive terminal voltage is greater than the negative terminal voltage. So you will get nothing, it is just a 1. Now if you will get the 1, then control circuit will say to the ring counter what you want. Ring counter will say give me the clock. And now if you will give the clock, I will make this 0 to 1 and I will make this 1 to 0. So actually ring counter will make this 1 and they want to make this 1 to 0. But as we know, the control circuit having the input 1, they are going to hold it state. So the next state will become 0111 and in the last bit will become 1. Immediately the ring counter will send EO signal to the user ki whatever you have given, I have completed that task. So the conversion will be nothing, it is just a corresponding to 7.9 volt. Corresponding to the 7.9 volt, the conversion time digital output is 00111. Now we do not require any circuit to operate it. Very simple, we can solve. Without the circuit also we are able to make the state flow diagram. So how? Look at here, everyone. Suppose I am giving you 13.5 volt and I am asking how the state flow diagram is going to be formed. So everyone try to understand. How this state flow diagram without the circuit we are going to form. Everyone try to understand. First we have to apply SOC. In the last we have to apply what? EOC. Now you can observe everyone. After applying the first clock, the state will become 100. 100 is called nothing, it is just a 8. Now 100 is called 8, so 8 and 13.5 is compare. Always try to understand, whenever you want to increase this value, we have to hold the 1. If you want to decrease this value, simply shift the 1. Do not hold it. Only you have to remember this one statement. If we want to increase this value, we have to hold the previous one. If you do not want to increase this only shift the 1. Do not hold it. That's it. Sir, 8 and 13.5, which one is greater? Sir, this one. We have to increase this value. We have to make it compatible. So we have to increase this value. Increase the value, so hold it. Hold it and the next bit will become 1 by the ring counter only. Now this will become 12. 12 and 13.5. So this one is greater. Increase it, increase it, increase it. Now if you want to increase it, hold it. For the increment, hold. We have to hold it. So if you will hold it, now this is called 14. 14 and 13.5. So this one is greater, sir. Reduce it. So reduce we want to have, only we have to shift it. So 1, 1, 0, 1. This one is the conversion. Amita, absolutely correct. This one is the conversion. Preeti, absolutely correct. Everyone understood? Write down yes or no in the comment box. If you understood this concept, write down yes or no in the comment box. Is still people having the doubt? I will share one more example I will give you, right? Suppose 9.75 volt is there. How we are going to make directly the state flow diagram? Okay. start of conversion. And now if you want to discuss about the end of conversion, बिल्कुल consumer 4 clock ही लगेंगे. How we are going to do it, everyone? Sir, if you want to write the operation, the first, it will become 1000. This is called 8 and 9.7. Sir, increase this value. Increase this value, sir, because it is a smaller value. How will increase this value? Hold the previous one. So if you'll hold the previous one, 12. Sir, 9.7. Decrease this value, sir. Decrement only shifting. 9.7, 10. Decrease this value is, sir. Only shifting. Khatam. This is called state flow diagram. So very simple, you can observe, everyone. Maybe in this particular topic only 2 type of question we can expect. In this particular topic only 2 type of question we can expect. What? The one is related to state flow diagram. And the second one is called minimum conversion time. 4 bit is there, that's why only in the 4 clock we are going to convert it. If we 5 bit encounter is there, 5 clock is basically required to convert it. 10 bit encounter is there, 10 clocks are basically required to convert it. So we can say that minimum, maximum and average. All are basically fixed, that is called anti-clock. But in the question, suppose SOC and EOC also mentioned, and for the SOC and EOC 1 clock, for the SOC 1 clock for the EOC is required. Then we cannot say that only N. If SOC plus EOC is basically given in the problem, right? Okay, this one also required 1 clock. Then your answer will be nothing, it is just a N plus 2T clock. So always, whenever this type of question is given, you have to be very, very conscious कि whether the SOC and EOC mention in the problem or not. If it is a mention, then the conversion time is N plus 2T clock. If it is not mentioned, the conversion time is simple NT clock, right? Why I am writing this 2? 1 for SOC, 1 for EOC. If they will give you 1 clock, is for this one is also required some time. Then we have to write. And one thing more, here you can feel always it is a fixed. So always you have to remember the conversion time is independent of analog voltage. Conversion time is independent of analog input. Conversion time is always fixed for that, right? No. Maximum, if SOC and EOC is given, then maximum, minimum, average, all. Maximum, minimum and average. All are basically this. Right? So hope you guys understood what should be the meaning of this, right? If you understood it, now we are moving into the next. Third one, so in the, everyone, right? Okay. Again, Vignesh, depends upon the resolution will depends upon this one only. DAC only. Resolution will depends upon the DAC of the resolution only. Right? Okay. Now we are going to discuss the next one, that is called 3-bit flash type ADC. Everyone try to understand. In the 3-bit flash type ADC, only we can expect the one question. What? If n-bit flash type is there, if n-bit flash type is there, ADC is there, then how many resistance are basically required? How many resistance are basically required? 2 raised to power n resistance are required. How many comparator are required? 2 raised to power n minus 1 comparator are required. Which type of encoder is basically required? 2 raised to power n cross n priority encoder is basically required. Priority encoder is required. The one question we can expect from here, right? And one thing more in this topic you can understand, this flash type ADC is the fastest ADC among all the ADC. Fastest ADC among all the ADC. How they are going to work, everyone try to understand. So one question, suppose we are designing the 3-bit. Suppose we are designing the 3-bit flash type. So how many resistance are required? 8. 2 raised to power 3, 8. How many comparator we can require? So 2 raised to power 3 minus 1, that is called 7 comparator is required. Which one is the encoder is required? 8 cross 3 priority encoder are basically required. That's what you have to remember. Now how this is going to be work, everyone try to understand. Minus plus minus plus minus plus minus plus minus plus minus plus minus. Right now I'm taking, this is called I0, this is called I1, this is called I2, this is called I3, I4, I5, I6, and this is called I7. Suppose I'm taking the 8 resistance, this is called 8 resistance, all having the value R. So 8 resistance, so all voltage, that is called VR, is basically divided by the 8 equal voltage, right? Every resistance having the voltage drop VR by 8. So here if you want to find out the value, this is called VR by 8. Here if you want to find out the value, that is called 2 VR by 8. Here if you want to take the voltage value, 3 VR by 8. Here 4 VR by 8. Here if you want to discuss 5 VR by 8. Here 6 VR by 8. And here if you want to discuss 7 VR by 8. This is called like this, right? Okay. शुभम सर डिले गेट 2022. शुभम आपको क्या लगता है, आई एम द राइट पर्सन? इवन आई एम द राइट पर्सन? अगर वो लगता है कि आपको हाँ मेरे पास पावर है, आई विल डिले इट इमीडिएटली विद द इमीडिएट इफेक्ट, राइट? सो most important, whether the exam is going to be postponed or exam is not going to be postponed, that will be decided not by us, that will be decided by the or even that is not decided by the IIT. कि you are thinking ना कि sir IIT has to postpone, we are making the voice कि please postpone the even that is not in the IIT hand, believe me, this is not in the IIT hand. आपको लगता होगा कि IIT के हाथ में, no, this will depends only into the circumstances, right? और मेरा काम है, आई एम ऑलवेज सपोर्ट फॉर द कंस्ट्रक्टिव वर्क. आई एम ऑलवेज सपोर्ट फॉर द कंस्ट्रक्टिव वर्क. यस, आई विल ऑलवेज सपोर्ट राइट अप कि आई नो दैट द सर्कमस्टेंसेज इज नॉट दैट मच ऑफ गुड, द पीपल आर नॉट एबल टू मूव फ्रॉम वन पोजिशन वन प्लेस टू द अदर प्लेस. आई नो दैट, राइट? दैट्स व्हाई आई एम सपोर्ट विद द स्टूडेंट, राइट? बट योर राइट. हाँ यार साहिल भाई, मैंने कब मना किया कि आपका सपोर्ट नहीं है, पर मैं तो ये चाहता हूं ना कि गेट अगर फरवरी में ना हो कि मार्च में भी आए तो एग्जाम पोस्टपोन होना आपकी इतनी हेल्प नहीं करेगा जितना हेल्प करना ये जो मैं पढ़ा रहा हूं ना वो करेगा. एग्जाम पोस्टपोन भी हो जाएगा साहिल, तब भी एग्जाम वही फोड़ पाएंगे जो अभी इन फालतू की चीजों पे आपको पिटीशन फाइल करना है, डू इट. बट इफ यू कम इनटू दैट, यू कैन से दैट वीडियो और यू कैन कमेंट गेट पोस्टपोन हो जाना चाहिए, राइट? और यू आर वेस्टिंग द टाइम, एक्चुअली यू कैन से दैट. तो आप आपका भी नुकसान कर रहे हैं और आपका नहीं, आप दूसरों का भी नुकसान कर रहे हैं. साहिल मेरे भाई, एग्जाम पोस्टपोन होना चाहिए, आई विल एग्री विद यू, आई एम इन सपोर्ट, राइट? फुल्ली सपोर्ट. क्या चाहते हो वो कर देंगे, पर मेरे वीडियो बनाने से भी कुछ नहीं होगा, मेरे चिल्लाने से भी कुछ नहीं होगा, राइट? लेट द सिचुएशन विल हैंडल दिस पर्टिकुलर कंडीशन और उसके हिसाब से ऑटोमेटिक ही हो जाएगा. वी हैव टू कंसंट्रेट ऑन दिस टॉपिक. और मैं आपको बता देता हूं साहिल भाई, बिलीव मी, who are the topper now, they are going to crack that particular exam. They are studying, they also know कि maybe the exam is going to be postponed, but they are also study at this particular moment rather than they are participating or they are wasting the time, right? कैंपेन चलाओ, धरना करो, जो करना है करो, बट भाई पढ़ो, जरूरी है, पढ़ना जरूरी है. सपोर्ट तो साहिल है ही, अब सपोर्ट कैसे करूं बताओ? चौराहे पे जाके डांस करूं? सपोर्ट कैसे करूं? मुझे पता है कि सिचुएशन गड़बड़ है. इवन आई एम ऑल्सो, वॉट एवर जो आप फील कर रहे हो ना फ्रॉम द लास्ट 3 days, बिलीव मी साहिल भाई, आई एम ऑल्सो सफरिंग द सेम सिचुएशन व्हाट यू आर टॉकिंग अबाउट टू एग्जाम द पोस्टपोन. इवन आई एम टेकिंग द क्लासेज ऑल्सो एंड आई एम सफरिंग, राइट? शायद जो मेरे पेड कोर्स के बच्चे जो कोई देख रहे होंगे उनको भी पता होगा कि मैंने उन क्लास के अंदर बोला भी दिया था कि आई एम ऑलरेडी सफरिंग इन टू दिस, देन ऑल्सो आई हैव टेकन द लॉट्स ऑफ क्लासेस. तो आपको देखो, सीरियस और नॉन सीरियस में 2 ही चीज है. नॉन सीरियस क्या करेंगे? टाइम वेस्ट करेंगे, टाइम पास करेंगे. और जो सीरियस स्टूडेंट है वो एक अडिग डिसीजन लेंगे, वो काम करेंगे कि पिटीशन फाइल करना है, ट्वीट करना है, जो करना है करेंगे और उसके बाद सीधा पढ़ने पे आ जाएंगे, राइट। तो और साहिल देखना, अगर तुम अभी से भी सही सुधरे ना, अगले साल फिर तुम इसी चैनल पे मिलोगे और फिर यही बोलते मिलोगे सर एग्जाम पोस्टपोन कर दो, राइट। साहिल वीडियो बनाना, यार मतलब बच्चे क्या दिमाग ही नहीं है यार उनमें, पता नहीं, इनको लगता है कि मैं जोर जोर से चिल्ला दूंगा एग्जाम पोस्टपोन होना चाहिए, हाँ एग्जाम पोस्टपोन कर दो, राइट, तो उनको एग्जाम पोस्टपोन हो जाएगा। मतलब बच्चा समझ ही नहीं पा रहा इस चीज को कि आपके हाथ में 2 ही 3 चीजें हैं, मेल करिए आईआईटी को, गवर्नमेंट को, एमएचआरडी को मेल करना है, एमएचआरडी को मेल करिए, आपको अगर ट्विटर पे ट्वीट करना है, ट्वीट पर इन सब में कितना टाइम लगता है, 15 मिनट टाइम लगता है, पर आपको लगता है कि आप बाकी की दुनिया में जितने भी क्लासेस चल रहे हैं, चैनल चल रहे हैं, उस चैनल पे जाके लिखोगे पोस्टपोन द, उससे कुछ फर्क नहीं पड़ेगा, उससे तुम टाइम वेस्ट कर रहे हो, राइट। राइट, ओके। और साहिल अभी भी बोला सर वीडियो बना दो। अब साहिल तुमको क्या लगता है, अमित शाह जो मेरे चच्चा लगते हैं कि मैं वीडियो बना दूंगा तो एग्जाम पोस्टपोन हो जाएगा, राइट। I will make it, don't worry about that. Okay. Let's come on the topic, guys. 3-bit flash type ADC. Fastest ADC, we can say that, right? Now this is called resistance 2 raised to power n, comparator is called 2 raised to power n minus 1, and encoder is called 2 raised to power n cross n, right? Soda, I am also exam positive, right? Believe me, I am also positive. मेरी वॉइस से भी लग रहा होगा, जो बच्चे देख रहे हैं जिन्होंने पहली वॉइस सुना होगा, सफरिंग फ्रॉम द फीवर, राइट, जो गला है वो चौक हो रखा है, एंड द सेकंड वन इज कॉल्ड कोल्ड, राइट। ये 3 सिम्टम्स हैं और वो सिम्टम्स मेरे साथ भी है, राइट। पॉजिटिव भी हूं, इवन दो वॉट एवर आई हैव टास्क, आई एम इन द रूम, आइसोलेटेड रूम इन माई स्टूडियो, राइट, और आई एम टेकिंग द क्लास इन वेरी अप्रोप्रिएट मैनर। तो स्टॉप हो, गेट पोस्टपोन हो, नहीं हो, कोई फर्क नहीं पड़ता यार, कुछ भी हो। आ जाओ अपने टॉपिक पे अपन। तो फास्टेस्ट ADC among all the DDC, sir, how it will be going to be work, so everyone try to understand. Suppose let me discuss about the priority encoder, how they are going to work, right? Suppose this bit is 1 and all bit is basically going to be 0. अब forget about the MSB LSB, मैं एक simple example ले रहा हूं। This is going to be 0 0 0, this is going to be 0 0 1, this is 0 1 0, this is 0 1 1, this is called 1 0 0. How the priority encoder table is there? मधुकांत कर रहे बेटा, राइट। जो मेरे हैंड में है ना, आपको नहीं पता होगा मैं क्या कर रहा हूं, बट वॉट एवर इन माई हैंड आई एम जस्ट डूइंग इट, डोंट वरी। रवि, आई नो दैट। पता नहीं, मतलब one thing I want to share, everyone try to understand, one information I want to share. Whatever the channel is, this is not a channel for, you can say that, suppose I am taking the digital electronics session, right? So that all the things is basically not decided by me कि if you want to make the video और मैं बोलूँगा और वीडियो मेरी क्लास लग जाएगी, it's not, it's an organization and there are some steps. What type of the session I have to take now, that is not only decided by me, that is decided by the hierarchy. So whenever the people are basically saying make the video is like this, we are not authorized people to make those particular videos until unless that will, but yes, we are always in the support, right? Always in the support. मैं तो, तुम जो पूछ रहे हो, एक बार मेरे पुराने वीडियो जाके देखो, इन द एवरी वीडियो। मैं तो अभी भी मुझे गट्स फीलिंग आ रही है कि एग्जाम पोस्टपोन होगा, मुझे अभी भी फीलिंग आ रही है। इन उदयपुर ऑलरेडी 800 cases in the one day, in the last day, and Udaipur is very small city, you can feel. Even there will be the weekend curfew is there, lots of train was cancelled, right, already cancelled, flight was delayed or cancelled. So I know that the worst situation is not coming at this particular moment, that will be happened after the 25th, you can feel. 25th के बाद थोड़ी और सिचुएशन गड़बड़ होगी, तो मुझे लग ही रहा है, राइट? ओके, right now how this is going to be work, everyone try to understand. Now if you want to discuss about how it is going to be work, so everyone try to understand. This is called 3-bit flash type ADC. Now in the 3-bit flash type ADC, if you want to discuss, right, 3-bit flash type ADC, suppose I am taking the one example, right, and before going to that example, everyone try to understand. If analog voltage, applied analog voltage is less than VR by 8, then the encoder will provide 0 0 0. If analog input is lies between VR by 8 to 2 VR by 8, then conversion will be 0 0 1, right? If 2 VR by 8 to 3 VR by 8, the conversion will be 0 1 0. If 3 VR by 8 to 4 VR by 8, the conversion will be 0 1 1. If 4 VR by 8 to 5 VR by 8, the conversion will be 1 0 0. 5 VR by 8 to 6 VR by 8, the conversion will be 1 0 1. 6 VR 8 to 7 VR by 8, the conversion will be 1 1 0. And 7 VR by 8 to VR, the conversion will be 1 1 1, right? Now everyone try to understand. This is called like this. Now right, now everyone try to understand. Now everyone, how we are going to do it, everyone try to understand why not y1 and y2. Now suppose by the example I am just giving you the idea कि suppose VR is called nothing, it is just a 8 volt, right? So VR is called 8 volt, so here you are getting 1 volt, here you are getting 2 volt, here you are getting 3 volt, here you are getting 4 volt, here you are getting 5 volt, 6 volt, 7 volt, and 8 divided by, that is called 8 volt only. Now suppose analog voltage is 3.2 volt. How the conversion is going to be happen? So everyone try to understand. And why we are saying it is a fastest adder? Because resistance does not require any clock. This is called comparator. This is called combinational circuit. It does not require any clock. And this is called encoder. It does not require any clock, right? Hello Aditya. This does not require any clock. Now everyone try to understand. Sir, if you want to discuss about the conversion, now how it is going to be happen? Everyone, how it is going to be happen? So everyone try to understand. Okay, sir, this is called 8 cross 3 encoder. Eight cross 3 encoder. So everyone, if देखो, here the negative terminal is connected to 1 volt, but the positive terminal is connected to what? 3.2 volt. So positive terminal having the value greater than negative terminal, so you will get 1. It is already by default, it is 1, right? Now negative terminal is called 2 volt, positive terminal is called 3.2 volt. Again you will get 1. Negative terminal is 3 volt and positive terminal is called 3.2 volt. Again 1. Negative terminal is 4 volt and positive terminal is 3.2 volt. 0, 0, 0, 0. Now I3 is 1. Now if the I3 is 1, you can feel if I3 is 1, then independent of whatever their MSB is, according to that we have to take the decision, and the conversion will be nothing, it is just a 0 1 1. That's what we have converted without any clock, without any clock. Here also you can write, if we have taken the VR is called nothing, it is just a 8 volt. So if the message signal analog voltage is less than 1 volt, 0 0 0, 1 to 2 volt, 0 0 1, 2 to 3 volt, 0 1 0, 3 to 4 volt, 0 1 1. So this is called VA, we have taken as a 3.2 volt. So it will lies between 3 to 4 volt. Where is the 3 to 4 volt? This one. Conversion is 0 1 1. Here also we are getting the same answer. Deepak, don't worry, they will change the city. देखो, एवरीवन, देखो मैं उन सब चीजों के सपोर्ट में हूं. किस चीजों के सपोर्ट में हूं कि फर्स्ट, इफ दे आर गोइंग टू नॉट चेंज द टाइम or date, they are basically not changed, then at least open the what, open the center to be chosen. Again, center to be chosen. If any people are basically COVID positive, then let them 36 जो 300 जो 65 days उसने इन्वेस्ट किए प्रिपरेशन के लिए, उस प्रिपरेशन का वेस्ट नहीं होना चाहिए. He also allow to sit into the isolation. Train availability. Train availability. Train, flight, everything availability. If they are not going to change it. And even though if the situation is worst, तो कुछ चला के भी क्या करेंगे यार, हेल्थ अच्छा होगा तो ही तो काम चलेगा. Then postpone it. Then postpone it. No clock requirement in this type. Yes, definitely Vaibhav. No clock is basically required for this particular, right? So even we can take the some other example also. Suppose instead of 3.2 volt, if I will take 5.7 volt, how it is going to be happen? 5.7, so it is a 4 volt, it is a 5.7. This is also 1. 5 volt, 5. This is also 1. 6, and now this is going to be 0. So I5 up to I5, everything is 1. Now once the I5 is 1, we have to take the decision by the I5. Once the I5 is 1, do not care about the what before that value. We have to take the decision from the I5 only, that is called 101. And you can also feel value we have taken 5.7 between 5 to 6. Between 5 to 6, this one. Conversion is again 101. The same conversion is going to be happened, right? Right, okay. Now, so, but we cannot expect this type of question into the we cannot expect this type of question here. We can expect the question mainly into the flash type ADC. The how many resistance are required, comparator are required, encoder are required, and some output expression maybe they can form. Maybe they can ask, right? Right. Deepak, don't worry यार, हो जाएगा. अरे टेंशन मत लो. Now next one is called dual slope ADC. In the dual slope ADC, you have to remember the one word, guys. In the dual slope ADC, this is the slowest ADC. This is the slowest ADC among all the ADC. But most accurate. And here always you have to remember the two things. Okay, Dwarhat. Deepak, you are from Dwarhat. और from एक और कौन सा था यार उत्तराखंड में. Right, one thing more. Here we can remember always. The conversion time is basically depends like this. So we can say that everyone, this is called slope. Now everyone you can feel in the dual slope ADC, the conversion time, the maximum conversion time from where they can ask the question, maximum conversion time. Based on this we can expect the question, right? A minimum conversion time is 2 raised to power n only. Minimum conversion time 2 raised to power n only. And always you have to remember, suppose this value we can say that x and this value we can say that y. So always we have to remember that y is less than equal to x. Y is less than equal to x. So in the dual slope ADC, the one theoretical question, the slowest ADC among all the ADC, one maximum conversion time 2 raised to power n plus 1 into t clock. That's what the important, right? Okay, there will be some derivation also, but not required, right, in this particular batch. because we are revising in very quick manner, so it does not required. Now everyone, next we are going to discuss about the DAC, digital to analog converter. Yes, Monisha, correct. बिल्कुल दीपक, मुझे याद है अच्छे से, राइट, द्वार हाट, बट डोंट वरी यार, जो सिचुएशन होगा ना वो मुझे जहां तक लग रहा है आपके फेवर में जाएगा. ज़्यादा टेंशन मत लो, बस पढ़ाई को डिस्टर्ब मत करो, बस पढ़ाई करते रहो, जो आप चाह रहे हो आपके फेवर में चीज़ें होती रहेगी, कोई दिक्कत नहीं है. राइट, ओके. Now everyone try to understand digital to analog converter. Next DAC we are going to discuss. This is called nothing, it is just a weighted register type. Whenever any DAC is basically given, everyone try to understand how we are going to find out the V naught. For the weighted register type DAC is called nothing, it is just a output, analog output V naught equal to R into D into G. R into D into G, right? Always the formula is called nothing, it is just a, right? R into D into G. R is called what? Resolution. Whenever for the weighted register type DAC, if you want to find out the resolution, yes, mostly important DAC, yes, definitely. The resolution is called nothing, it is just a VR upon 2 raised to power N minus 1. Here with the N only the minus 1 is there. Only for the DAC you have to remember this resolution. And gain will depends upon whether the inverting or non-inverting is there. According to that we have to use the gain. Decimal equivalent, we already know that whatever the value is there, if the switch is connected to VR, we have to consider as a 1. If switch is connected to the ground, we have to consider as a 0. With the question we are going to discuss. Sirsha, don't worry, there will be no confusion. I will write everything into the one sheet, so you will get the idea, right? Always you have to remember this is called nothing, it is just a V naught, R into D into G. Here if you want to find out the V naught now, you will get in this particular circuit VR upon 2 raised to power 3 into summation of I equal to 0 to N minus 1 2I BI into minus RF upon R. So you can feel this is called gain, this is called decimal equivalent, and this is called resolution. In this particular case, इधर मैं लिख देता हूँ 3 only. Right? And that's why in the generalized form, if you want to write, always you have to remember R into D into G is called nothing, it is just a output, right? Analog output. Now if you want to discuss the next one, everyone. So already we have discussed when weighted resistor is given, when weighted resistor is given, always analog output is called nothing, it is just a R into D into G, and R is called nothing, it is just a VR upon 2 raised to power N. N के साथ minus 1 use करना है for the weighted resistor type, right? Good afternoon, Monica. देखो, here you can derive it also. How? Everyone try to understand. The derivation will become very simple. It is called I1, it is called I2, this is called I3, this is called I4. This is called total II. And as we know the op-amp is ideal, there will be no current will go inside the op-amp. So here you will get nothing, it is just a IF. So II or IF is same. So if you want to move it, II, how we are going to find out? Sir, II is called nothing, it is just a I1 plus I2 plus I3 plus I4. How we are going to find out the I1? Sir, I1 we will write like, sir, VR upon R into B3. If B3 is connected to ground or it is connected to VR. If it is connected to ground, we have to take as a 0. If it is connected to switch is connected to VR, we have to take as a what? 1. Here if you want to write I2 VR upon 2R into B2. Here we can write VR 4R into B1. VR upon 8R into B0. This one we have calculated. This is the current II. Add it, all the current. Yes, definitely. So if you want to add it now, IF equal to II equal to I1 plus I2 plus I3 plus I4. By the network you can solve this question, right? VR upon R into B3, VR upon 2R into B2, VR upon 2R, यही था ना, 4R into B1, VR upon 8R into B naught. Okay. Now you can take everyone, this is called IF. And now we already know that how the voltage you will get. So this voltage is called nothing, it is just a plus minus V naught. So IF into R, RF, this will give you nothing, it is just a V naught. Minus sign with this we can write VR by R B3, VR upon 2R B2, VR upon 4R B2 B1, VR upon 8R B naught with the minus sign, and here I am taking RF. This one the value you will get. Now V naught equal to, I am taking VR upon 8R as a common, VR upon 8R as a common, and here I am writing minus RF upon R. R also I am taking common. So here you will get what? 8B3, 4B2, 2B1, 1B naught. And we can write V naught equal to VR upon 2 raised to power 3. 2 raised to power 3 B3. So we can also write this one as a I equal to 0 to 3 2I BI into minus RF upon R. So you will get now, this is called resolution for the 4-bit we are discussing. So VR upon, this is called resolution. This one is called decimal equivalent and this one is called gain. So R into D into G. And that's what I have given. That's why I have written, right Harry? That's why I have given separately, I have written this resolution formula. For the 4-bit you can feel here the 2 raised to power 3 is there. So 5-bit 2 raised to power 4, n-bit 2 raised to power n के साथ ही minus आएगा. Are you getting my point? I have derived it also. So again everyone try to understand, do not focus on this. Whenever this will give, this type of circuit is given, always you have to remember this one is called LSV, this one is called MSV. According to 101 you can calculate into the decimal equivalent, into multiply with the resolution. And how we are going to find out, again एक बार फिर से लिख देता हूँ. V naught is called nothing, it is just a R into D into G. But here for the weighted resistor type, R is called VR upon 2 raised to power n minus 1. Simple. अरे हरी अब तो बता दो यार, अब तो derive भी कर दिया. Already I have derived. Okay, now if you understood it. Second one is called R2R ladder type. How we are going to solve the question by the R2R ladder type is basically there, guys. How we are going to solve it. So everyone try to understand. This is called 4-bit R2R ladder we are taking. 4-bit R2R ladder we are taking. Yes, definitely Rahul. Approximately equal. Approximately equal. Now how we are going to convert it, everyone try to understand. This is called RF. And this is called R, this is called 2R, 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 this is called 4-bit, right? I am taking, this is called MSV and this one is called nothing, it is just a LSB. Now there will be the different RF, I am taking the RF. Now everyone, how we are going to, even we can derive it also. I am just giving you the brief idea. Suppose we are forming the case 1. That is called VD, VD, VC, VD, VC, VB, VA. 4-bit is there. I am taking as a 1, 0, 0, 0. If you take the 1, 0, 0, then what should be the circuit diagram is? For this circuit diagram is. So circuit diagram is basically looking like this. Everyone try to understand. Circuit diagram, if you want to discuss how it will be happen. Here it is connected to VR and all are basically connected to ground. This one is the circuit you will feel. Definitely M Shirsa absolutely correct. So this one we can say that this is called nothing, it is just a 2R. 2R, 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 and this is connected to the input of the op amp. Right? This is called R, this is called R, this is called R. Okay. Now everyone try to understand how we are going to solve it. So this 2R and 2R is basically into the parallel. If 2R and 2R in the parallel, everyone try to understand, the 2R and 2R is parallel, how we are going to write it? Oh, ये चेंज नहीं होगा. Okay, so if it is a parallel, so how we are going to write? Sir, we can draw this circuit like this. 2R and 2R parallel, so you will get the R. Now here you will get nothing, it is just a 2R. Sorry, R, 2R, R, 2R, R, 2R, 2R. This is called Vn. Now you can feel, everyone, this R and R again in the series, and this R and R in the series with the parallel with this 2R. So if you want to solve this question, this part, again you will get the value is R. Why? Because this R and R in the series with the parallel with the 2R. So 2R parallel with the 2R, you will get the R value. So you will get R. And apart from this, if you want to write it, everyone, जिसको तो हमने बोल दिया R. Now this one is basically given R 2R R 2R R 2R R 2R. Here VR is given. This is ground, and this is your Vin. 2R 2R R and R. Again you can feel, everyone, try to understand. This R and R is given again in the series. So it will become 2R, and 2R parallel with 2R. 2R parallel with 2R, again you will get the value of R. So if you want to solve this circuit, you will get it. Actually the circuit you will get nothing, it is just a R only. Or R with the R, that is called 2R. You will get So here if you want to find out the Vn, what should be the VTH for this particular circuit? Sir, voltage dividing rule, this is called 2R, this is called 2R, voltage dividing rule. So by the voltage dividing rule, resistance value is equal. So definitely VR by 2 is basically divided. So VTH is called nothing, it is just a VR by 2. And RTH of this circuit is already R. So we can represent entire circuit in this configuration. Entire circuit we can represent like this is called R, equivalent is R, and this is called VR by 2. Entire circuit we can write like this. And now what should be the actual representation of this particular circuit? So actual representation of this particular circuit is how we are going to find out the V naught. V naught is called nothing, it is just a gain into input. So gain is called minus RF upon R into VR by 2. This one is the output in this case you will get. So now by this you are able to decide every case you can design, right? It means, everyone, suppose the case 2 if you are forming. Case 2. VD, VC, VB, VA. And this is called 0, 1, 0, 0. Now if you want to write the VTH, you will get the VTH is called VR by 4, and RTH you will get nothing, it is just a R. In this particular case, in the same manner you have to solve. Suppose here it should be the VR is there and all are basically ground. Then how we are going to solve it? Right, like that. So in this case you can feel this is the circuit. So this is called nothing, it is just a circuit. How we are going to do it? So here now you will get the output minus RF upon R into VR by 4. Now like that every circuit you will get. So everyone try to understand. We can write in the very systematic manner. VD is there, VC is there, VB is there, VA is there. Corresponding to MSB, the RTH is called nothing, or VTH is called nothing, it is just a VR by 2. Corresponding to V2, this is called VR by 4. Corresponding to this is called VR by 8. Corresponding to this is called VR by 16. Like this it is going to be happen. So if you want to find out the decimal equivalent, everyone try to understand how we are going to write it. So if you want to write VR by 2 into what? B3, or we can say that B4. B node, B1, B2, B3. VR by 4, B2. Whether it is connected to 1 or connected to 0. According to that we have to write B. VR by 8 into B1. VR by 8 into 16, that is called B node. Or people basically, whenever I'm deriving the expression, because the people are basically having the doubt into the resolution, and whenever I'm shorting out the resolution doubt na, then the people having the doubt, again people are basically leaving this. मतलब ऐसे में मजा नहीं आएगा यार, सही बता रहा हूँ, very serious. Setup time, whole time I will not going to discuss, right? This one is called VTH into what? Multiplied by minus RF upon R. This is called your V note output. So now if you want to find out the V note, I am taking the VR by 16 as a common. So it will become 2 raised to power 3 B3, 2 raised to power 2 B2, 2 raised to power 1 B1, 2 raised to power 0 B note. And you will get V note equal to nothing, it is just a VR upon 2 raised to power 4, 0 to 3, 2I BI minus RF upon R. Again you will get, it is called resolution, decimal equivalent, and it is called gain. So in this case you can feel, everyone, in this case you can feel कि whenever the V note is called, again R into D into G for R to R ladder type. But here the formula is R is called nothing, it is just a VR upon 2 raised to power N. Simple, VR upon 2 raised to power N. So everyone try to understand, think 3 cases I am giving you. Always this is called R into D into G. For output we have to write R into D into G. When weighted resistor is given, R equal to VR upon 2 raised to power N के साथ -1. When R to R is given, VR upon 2 raised to power N. And if name is not mentioned, this one we have to use. Now I think there will be no confusion on it. Monica, for the EC around 9 to 10 marks. For the EC around 9 to 10 marks we can expect. बिल्कुल Alan, आज match भी guys. Today is the mentee session also at 11 o'clock. Mentee session also at 11 o'clock, right? Right, so we can say that now. Directly we are coming into the question, everyone. A 12-bit ADC is there, everyone. A 12-bit ADC, everyone quickly responds for this question, guys. A 12-bit ADC is operating with a 1 microsecond clock period, and the total conversion time is seen to be 14 microsecond. T clock is given 14 microsecond. N is given 12-bit. So which type of ADC is it will be, everyone? Kaja Sai has given the responded for this, everyone. Everyone quickly respond for this. Yes, everyone. We already know that this is the answer is called nothing, it is just a SAR. Why? Because the conversion time to T clock. N is called 12. T clock is 1 microsecond, not 14, 1 microsecond. 14 plus 2, 1 microsecond. So conversion will give you 114 microsecond. So 14 microsecond conversion time, it is a short that it is a SAR type ADC. So D is the absolutely correct answer of this question. बहुत ही बढ़िया. Now one more question, everyone, just give me the answer. The resolution of a 4-bit counting ADC is 0.5 volt. An analog input of 6.6 volt. The digital output of the ADC will be, what should be the digital output of the ADC? A is given 100. Everyone just give me the answer of this question. Quickly respond for this question. This is called counting type ADC, means what? Counter type ADC they are asking the question. How we are going to write? Yes, Kaja, Pujita, absolutely correct. Venu, Bhargavi, Rakesh, Jaya, bahut badhiya. Everyone, how we are going to solve this question? Sir, we already know that analog input upon resolution. Whatever the value is there, we have to write into the integer and then convert into the binary. So analog input is given what? 6.6 volts. 6.6 divided by resolution 0.5. 13.2. So next value integer 14. And 14 we can write 1110. So the correct answer of this question is D. D is the absolutely correct answer of this question. Hope you guys understood this point, right? If you understood it, now we are moving into the next. Everyone, in the SAR 8-bit successive approximation analog to digital, SAR type ADC is given. SAR type ADC is given. Conversion time has the full scale reading is 2.55 volt. Okay, VFS is also given. For 1 volt, the conversion time is 20 microsecond. Then what should be the conversion time for the 2 volt? Only for the 30 second I'm giving you for this question, guys. Yes. Sir, it is a SAR. In the SAR, we already know that conversion time is independent of the analog input. Conversion time is independent of the analog input. So whatever the conversion time is, it is always independent of the analog input. So for the 1 volt, it is 20 microsecond. For the 2 volt also, it should be 20 microsecond. Because it will not depends upon the what should be the analog voltage is connected. The conversion time is always fixed. That's why the correct answer is 20. The number of comparator in the 4-bit flash type. Number of comparator in the 4-bit flash type, 15 second question. 15 second question, guys. Conversion time is independent of analog input. In the previous one, here they are asking about the number of comparator. The correct answer of this question is C. How? So 2 raised to power n minus 1 comparator is required. 2 raised to power 4 minus 1, that is called 15 comparator is required. If they will ask about the resistance, then 16 resistance are required. Okay. Everyone just give me the answer of this question. 4-bit DAC shown in the figure 1 below. Output voltage V note is. What should be the output voltage? This is DAC is given. Always you have to remember resolution R. Sorry. This is called R2R. This is called R2R, right? So in the R2R resolution, we already know that VR upon 2 raised to power n. And analog output is called R into D into G. Resolution into decimal equivalent into gain. Let me find out the gain for this question. So it is you can say that input is connected to the non-inverting. So it's a non-inverting op amp. So 1 plus RF upon R. 1 plus 8K divided by 1K. Sorry, 7K divided by 1K. So you will get nothing. Gain is called 8. No. Right, Likhit. If R2R is given, that why you are using the -1 sign? Directly we can write now VR upon 2 raised to power n. Decimal equivalent, this is called MSB. This one is called LSB. 4-bit is there. 1010. MSB is this, so 1010. Decimal equivalent, if you want to write 10 volt. 10. Resolution VR is called 1 volt. Reference voltage is called 1 volt. 1 upon 2 raised to power 4. Decimal equivalent 1010, that is 10. Gain is called 8. 5 volt is the answer for this question. Simple to write R into D into G. Resolution formula for the R2R, it is a R2R given, VR upon 2 raised to power n. VR is given 1 volt. 4. So the correct, it's not, Raminder, it's not, you can say that B is the correct answer. Yes, correct. Hope you guys understood how we are going to solve this question. Everyone write down yes or no if you understood this question. If you understood it, now we are moving into the next. Minimum number of this 8-bit is given 255. Few question, take it as a homework, guys. This question I am giving you as a homework. You have to remember the D3, this D3, this is D2, this 1 D node. This is always 0. This is called Q2, Q1 and Q0. This is just a simple 3-bit up counter. Right, take this question as a homework. Everyone, can you solve this question? Okay, if you understood it, now we are moving into the next. Let me solve this question. This is called Johnson counter is given. Yes, correct. Can anybody give me the answer of this question? This is a Johnson counter is given. How we are going to find out? Sir, Johnson counter, we already know that. Sequence of the Johnson counter having the series 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1. Again, it will be start from 0, 0, 0. So if DAC will convert this into the digital value, this is called 0, 4, 6, 7, 3, 1 and again 0. So first 0 to 4 step change. 1, 2, 3, 4 step change. Then 2 step change. Then 1 step change. Then 3. Then 1. A is the absolutely correct answer of this question. देखो, after 0, then 4 step change, then 2 step change, then 1 step change, then it will come into the 3 value, then 1 value, then 0. Again, it is going to be start. So A is the absolutely correct answer of this question. Okay, directly we are coming into the FSM, right? Now guys, quickly we are going to we are coming into the what? FSM, finite state machine. There are some questions is basically given into the PDF. Try to solve those questions also after the class, right? Okay. Now everyone, there will be the two type of FSM means finite. Now we are going to discuss about the finite state machine. Right, okay. In the FSM, 3 things we are going to cover, right, in the today's class. In the FSM, 3 things we are going to cover. 1, how we are going to design the any sequence detector. How we are going to design any sequence detector. Santosh, sir, PDF. Santosh, you will get the PDF into the Telegram channel. I have already shared the link. Let me share one more time. Right? Okay. So first, sequence detector we are going to discuss. Then we are going to discuss how we are going to find out the output if the sequence is already given. And third one, we can say that how the state reduction method is there. How we are going to reduce the state, right? So everyone, finite state machine. Always you have to discuss there are 2 type of FSM we can design. One is called Muri and second one is called Mealy FSM. Muri FSM and Mealy FSM. In the Muri FSM, always you have to remember the output will depends, or the output of the Muri will depends only on the present state of input. That will depends only on the present state. It will never depends upon the input. Whereas in the Mealy FSM, if you want to discuss, the output will depends upon the what? Output will depends upon the present input as well as the present state also. So here you can say that the output will depends upon the previous state as well as, or present state as well as the input, both. But here if you want to discuss, it will depends upon what? Only in the present state, does not depends upon the input. RK channel already have given so many times, I have informed that there will be some issue happened while downloading the PDF of the digital part 2 from the you can say that from the smart board, and that's why we have not uploaded till now. But right, soon we'll try whenever we'll, यार पता हूँ 8-8 घंटे की 7-7 घंटे की क्लास चल रही है. In between the class, even I'm not getting the time to write down by my hand. Right, I will send it. Don't worry. Muri and Milli FSM. Right. Okay. Next one is called, if it will depends upon the previous state only. So whenever you will apply the clock, so by the triggered the clock, the output is going to be changed. Applying the clock, the output is going to be changed. But here we can say that the output is going to be changed only when the clock is applied. But output change as soon as any input is basically changed. They have to sense the input also, because it will depends upon the input. So definitely it will available, or it will provide the output when the clock is available. But along with that, they have to conscious regarding to the input also. They have to focus on the input also. Always everyone try to understand. If you want to design by the Muri FSM, more hard, we can say that more hardware is basically required. More states are basically required, so more hardware is there. Here we can say that less number of hardware is required as compared to. In the Milli FSM, less number of hardware is required because less number of states are there. If less number of states are there, then the response will be faster. Then we can say that Milli is faster as compared to what? Muri. This is little bit, you can say that more delay is associated with the Muri because more hardware is required to design it, right? Okay. How we are going to discuss, everyone try to understand. Whenever we are forming any state now, everyone try to understand. Whenever we are writing any state, guys, try to understand. Okay. The name of the state we can write here only. S note is called, but nothing, it is just a name of the state. And this will give you nothing, it is just a tell. Tell will give you the previous state. And now what should be the next state of that? That will be represented by the head only. Right? And input and output we can write here. So X is called nothing, it is just a input. And Y is called nothing, it is just a output. X is called nothing, it is just a input, and the Y is called nothing, it is just a output. Sir, which one is this representation? This representation is called nothing, it is just a for the Milli. Milli representation, right? Okay. How we are going to design the double one detector for the Milli? So everyone try to understand. Suppose we are at S note state. So double one detector means what? The conjugative to 1 if you'll get, then your output is going to be high. That's what we can say that double one detector. So suppose in the initially if the anybody will give you the 0, we are not going to move into the any state, right? Output is going to be 0. But if anybody will give you the 1, output is 0, you will reach to the what? Next one, and the output is going to be 0. It means you will reach to the S1 when single 1 is basically given to you. And now if anybody will apply again the 1, you have to maintain on this, and 2 1 is there, the output is going to be high. But what happened when you are at S1 and anybody will provide the 0? So the sequence is going to be broken. We have to start it again. We have to start it again. Again, the people having the doubts, sir, I am not understanding it, how it will be designed. So everyone try to understand. I am just giving you the example. Everyone try to understand. Suppose there are 3 categories are there. Suppose there are 3 categories are there. 1 category, 2 category, and 3 category. Suppose there are 3 categories are there, right? Okay. In this category, when people having the 10 rupees, alright, then the people will come into this state. If the people having the 10 rupees and 100 rupees note, then the people will come into this particular category. And if the people having 10 rupees, 100 rupees and 500 rupees note, then people will come into this category. There are 3 different categories are there. और अभी यार थोड़ा सा पानी पीने दो. Just give me 1 minute, guys. Everyone up to this portion, because there are three states are there. People having now everyone try to understand. Suppose you are in this state. Suppose you are in this state and the people has given 10 rupees to you. We are in this particular state only when we have a 10 box or 10 rupees in our pocket. Then only we'll reach to this particular state, right? Okay. कहने का मतलब जब आपको कोई 10 रुपए आपके पास जेब में हो तो आप इस स्टेट पे हो, जब 10 और 100 रुपए हो तो आप इस स्टेट पे हो, और जब 10, 100 और 50, 500 का नोट हो तो आप इस स्टेट पे हो. Clear? Thank you, beta. Okay, now everyone, suppose if anybody is basically giving you none of the rupees, or even they will give you the 10 rupees, we are not able to move into the next position. We are belongs to those family or those category only which having the 10 one or one 10 rupees or not, and so output is going to be 0. We are not going to move it. Now suppose if any people are basically giving you now 100 rupees to you. Now we'll move into this particular state that is called S1. This is the state where the people having the 10 rupees and 100 rupees. We have a 10 rupees and now we have the 100 rupees also given to you. We'll reach. But we require 10, 100 and 500 note. So the output is not 0. Output is not 1. Output is going to be 1 only when whatever the desired value is we have achieved. Then only the output is going to be high. Now suppose you are in this state and again the people are giving 500 rupees to you. We have to retain on this state only. The state is not going to be changed. Alright, okay. Suppose every amount is taken back and you are coming to the 10 rupees. You have to maintain this state only. Right, okay, now again, you are at S1 state and the people will give you 100 rupees, 500 rupees. Now whatever the desired value is, we have achieved it. And we have to reach to the what? This value, S2, this value. And now you are at this particular value. And now suppose it means you have a 10 rupees, 100 rupees and 500 rupees. Suppose anybody taken 500 back to you. You are in this state and 500 rupees back to you. Then you have to reach to this particular state. If 100 and 500 rupees back to you if taken, you have to again come to this state. Are you getting my point? So the state basically belongs to some particular values, right? Okay, sir, got your point. Now everyone try to understand how we are going to design it. Suppose you want to design 1-1 detector. Suppose you want to design the 1-1 detector. How we are going to design it? Sir, if you want to design the 1-1 detector, suppose you are at S0 state, which have nothing one. There will be no zeros or there will be no single one is there. This is the initial state. So if anybody will provide the 0, we are not able to move into the further state because if you want to move into the further state, we require the 1 at least. Now suppose the people will give you 1. So you come into this particular state. आपको जैसे किसी ने 1 दे दिया, आप इस स्टेट पे आ गए हो, बट अभी भी मुझे 2 1 नहीं मिले. There are 2 1. So output is 0. But yes, whatever it means, the S1 belongs to those category when the people having given the single 1 to you. It means now you have given the single 1 and you are come to the what? S1 position. Now you are in the S1 position. Maybe the people will give 0. Array sir, sequence is broken. We required 1 1, 2 1 consecutive. But if anybody will give you 0, the sequence is broken. Again we have to start it. But what happened if you are in this S1 state and the people will give you again 1? Oh sir, 1 1 we have achieved. So we have to retain on this state. 1 is given and output is going to be 1. Again the people will give you 1. Again it has to 1 because these 2 times 1, these 2 times 1. So again the output is going to be 1 1. Again the people will give 3 times 1. But here the output is, again the input will be 0. Again the sequence is going to be broken. It will be start. Again the people having the doubts, sir, I am not getting it. No issues. One more example I am giving you, everyone. Suppose we want to design 101 detector. How we are going to design it, everyone? Okay, now everyone try to understand. We are designing 101 detector. How we are going to design it? Everyone try to understand. No shoes, Nitish, अब try करो समझने का. Sir, we required 1, output is 0. We required 0, output is 0. And if you required 1, then output is 1. Because you will reach to this particular state when input is 1, after that input 0, after that input 1 is basically required. So whatever they required, it will given 1 0 1 0. Right, okay, now. So this is a very simple, what we required, we have made it. Now, we required 101, try to understand. So if we do not require 0 in the initial, whenever they will give you 0 into the initial, we are not going to start the sequence. Right? Shikla Udaipur. Now, if S1, if you want to discuss, if you are at S1, when you will reach to the S1, when single 1 is there. So if the single 1 is applied, now we have reached to the S1. What we required 101 detector. So everyone try to understand. आप S1 की state पे हैं, you are at S1 state. And now again the people will give you 0. We'll move into the next state because 1 0 is basically required in the conjugative manner. But suppose the people will give you 1. Whether the sequence is going to be broken? No sir. क्या sequence बिगड़ गया है? नहीं बिगड़ा है सर. अभी भी, right? अभी भी आप ये कह सकते हो कि सर अभी भी मैं 101 बना सकता हूं. Again we can make the 101. It means again after the 1 we are at S1 state and we have a 1. अभी भी अगर किसी ने 1 दिया तो आप बोलोगे अभी भी हम उस स्टेट पर हैं जिसके पास सिंगल 1 है. And which one having the single 1? S1. But output is satisfied, only 101 is basically there. बिल्कुल गजेंद्र उदयपुर. No, 101 we are detecting ना. Rahul, now when you will reach to the S2, so S1 का हमने पूरा देख लिया. Now for the S2, so we will reach to the S2 will reach to the S2 when 1 0 basically conjugative apply. If 1 apply, you will go to this state. If 0 applies, you will reach to this state. Now we are at S2 state, means we have a 1 0. Now maybe the people will apply 1, then we'll move into the next state. No issues for that. But what happened if the people will apply 0? You are at this state and the people as an input they will apply 0. Arey sir, we required a 101, but here the 0 is given. So entire sequence is broken sir. We are not able to make it. If you want to make it again 101, again we have to search 101. Oh, Gajendra Ajmer mein kahan se ho yaar? 101. So again we have to start it. So S2 का clear हो गया. Now if you want to add S3 will reach to the S3 when 101 is there. 101. Now here there will be the possibilities. Maybe 0 will give you and maybe 1 will give you as an input. So you are at 101 state and suppose 0 is given. Then again the sequence is not broken. You can feel 10 is there. Only 1 if it will become 101. So you have to move into those state there 10 is there. 10 is in this particular state, 1 and 0. In this particular state 10 is there. And now suppose if you are 101 state and suppose 1 is given, then again the sequence is not broken, right? Ram Bhavan Shastri Nagar, okay. Then you can feel the single 1 is there, right? Single 1 is there. Single 1 is what? S1. Khatam. This is called 101 detector. This is called 101 detector. Right? If you understood it now, one more example I am taking, everyone. Still the people having doubt, one more example I am considering. Suppose you want to design 1010 detector. How we are going to design it? अब देखो यार क्या क्या चाहिए for the 1010 detector. Now everyone try to understand what is required. I am writing this is called S note, S1, S2, S3 and this is called S4. समझो एक बार कैसे होगा. What we required? Sir, we required 1, output is 0, then 0, output is 0, then 1, output is 0, and then 0, the output is 1. Output is going to be high when all values are basically whatever we required, we have designed it. मूरी में स्टेट जो है ना वो इसी के साथ लिखते हैं. ओनली वी हैव टू राइट द इनपुट. वन मोर स्टेट इज बेसिकली रिक्वायर्ड. प्रीति, हाँ शिकला, ये सारा मिली का ही बता रहा हूं, पूरा हम आज की डिस्कशन मिली का ही करेंगे. राइट, ओके. नाउ एवरीवन ट्राई टू अंडरस्टैंड. इनिशियली इफ दे विल गिव यू 0, वी आर नॉट गोइंग टू स्टार्ट इट. नाउ यू विल रीच टू द S1 when single 1 is basically given. Then you will reach to this one. And now maybe the people will give you again 1. Suppose you are at S1 state means you have a single 1. Again the people are basically giving 1 to you. Again you are in the sequence. The sequence is not broken. Now suppose you are at S2 state. When you will reach to the S2 state? 1 0. 1 is given, then you will move into the next state. But what happens if 0 is given? So entire sequence is going to be broken. So they have to start it again. You are at S2 state means 1 0. Now 0 is given, you have to move into the next state. But what happens if 1 is there? Are sir, still we are in the sequence. We are on those state where the single 1 is there because we want to make 1 0 1. So we can think single 1 we have, and now 0 1 0 is required. So which one having the single 1? S1. So we have to move into the S1. प्रीति, मूरी का भी दूंगा यार, अभी बहुत सारी चीजें बतानी है. It will take a lots of time if I will discuss about the मूरी also. But don't worry, in the gate they will never ask about it is a million मूरी. They will give you the state like this. You have to find out the output only. Right? Okay. S4 if you are there, you will reach to the 1 0 1 0. Then it will reach to the S4 state. Now there will be the possibility if the people will give you 1. Again you can feel 1 0 1 is there. Only single 0 is basically required. So which one having the 1 0 1? This one. So it will goes to this state. If 0 is applied, 1 is applied. Now you are at S3 S4 state means 1 0 1 is there, and again the people will give you 0. Are sir, if people will give you 0, 2 consecutive zeros you will get. The sequence entire is going to be broken. We have to start it again. खत्म हो गया. We have designed it. Yes, correct Venu. So everyone understood or not? Write down yes or no. Any sequence detector if you want to write, you can design it. Very simple. Suppose I am asking one more question, everyone. Suppose I am asking 1 0 1 1 1 0 1 1. How we are going to design it? यहां पे हम स्टेट को बचा भी सकते थे, बट आई एम राइटिंग नो इश्यूज फॉर दैट. हम एक स्टेट को बचा सकते थे, बट नो इश्यूज. 1. नाउ एवरीवन ट्राई टू अंडरस्टैंड. इफ इनिशियली इफ यू विल अप्लाई द 0, one 0 is there, and if 0 will apply, we have to start it. 1 0 1, you can feel 1 0 1 is there, and suppose 0 is applied. Again, you are on those state where the 1 0 is there. 1 0 is there in the S2. Now you are at S4 state. When you will reach to the S4 state? 1 0 1 1. Now maybe possible if 0 will give you, you can feel again 1 0 is there. 1 0 means S2. And suppose you are at 1 0 1 1 state if 1 is given. You are at those state where the single 1 is there. S1. Khatam. Designed it. By state reduction you can reduce the one state, no issues. Now how we are going to design the sequence detector, we know that. Now we are going to discuss, everyone try to understand. Ki sir, how we are going to design the hardware? If the sequence detector is given, how we are going to design the hardware? Right? Suppose I am giving design a hardware which follow this sequence, right, by D flip-flop. How we are going to design the sequence detector? By using D flip-flop. Everyone, and then we'll discuss about the sequence. Then we'll discuss about the next one, that is called state reduction method also. एकदम से आप लोगों की स्ट्रेंथ ऐसी हो जाती है कि पता चला मन करता है कि छोड़ो यार, तबीयत भी खराब है, क्यों पढ़ा रहे हैं, छोड़ो, रहने दो. Right? Right now, how we are going to design the hardware, guys, for this? If you want to design by the hardware, it's very simple. If you want to design the hardware, you have to follow the synchronous counter design. That is the 5 step. Write the previous and present state. Second, write the excitation table of flip-flop. Third, write the logical expression. Fourth, minimize the logical expression. And fifth, hardware implementation. If you follow these 5 steps, you are able to design the hardware of this circuit also. Right? Okay. This one is called S note. This one is called S1. This is called S2. This is called S3. How we are going to design it? So everyone try to understand. S1, S note I am writing as a 0 0, already given in the problem, no issues. 0 0. S1 I am writing as a 0 1. S2 I am writing as a 1 0. S3 I am writing as a 1 1. How we are going to design it? So everyone. Now you have to design like, suppose I am writing this is called QA and this is called QB. Q I am taking as MSV and QB I am taking as LSV. This is called QA, this is called QB, and this is called input X. Combination will give you total 8, 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. 1 1 1, right? How it will be happen? So everyone try to understand. Now, next state if you want to write, that is called QA plus. I am writing QB plus. If you'll observe this one, already we have discussed, this is called 101 detector. This is called 101 detector, right? Okay. So you are at 0 0 state and if input is 0 is basically given. So again you have to retain on this same state also. 0 0. And what should be your output? Output is going to be 0. Now you are at 0 0 state and 1 is given. You have to come into the 0 1 state and output is again 0. Now you are at 0 1 state and input is 0. You have to go into the 1 0 state. Output is 0. You are at 0 1 state and input is 1. You have to retain on those state. 0 1 0. You are in this state S1, sorry S2, 1 0, and if 0 is given, you are at this state and if the 0 is given, दो कैसे हो गया, ये 0 होना चाहिए ना, हाँ 0. If you are at this state and the 0 is given, you have to move into this state. Output is 0. So 0 0. 0 is there, 0 state, it will be 0 0, output is 0. You are at 1 0 state and input is 1. You will move into the 1 1 state and output is going to be 1. Now you are at 1 1 state, this one, if the input is 0, you have to move into the 1 0 state. 0 pe na, हाँ, output is 0. And you are at 1 1 state and the input is 1. You have to move into the 0 1 state. 0. So we have written the previous and present state also according to that, right? Okay. Now if you want to write the excitation table, everyone, if you want to write the excitation table by D flip-flops, so DA and DB. QA plus we have to copy into the DA and QP plus we have to copy into the DB. So 0 0 1 0 0 1 1 0. 0 1 0 1 0 1 0 1. Now we have to write the equation. Yes, Shrinu. So if you want to discuss about the DA, this should be the function of what? QA, QB or QX. So if you want to design the DA, everyone, DA के लिए equation लिखोगे in the mean terms. DA is called 0 पे नहीं है, 1 पे नहीं है, 2 5 6 2 5 6. And if you want to write for the DB, one 3 5 7. Now how we are going to minimize it? So everyone, now we have to minimize the expression. QA, QB, QA, QB or X. X is the input, right? 0 0 0 1 1 1 1 0 0 and 1. QA, QB or X. 0 0 0 1 1 1 1 0 0 and 1. Sir, state diagram S1 has 2x0. S1 has 2x. Input 1. No. Input 1, this is for the, this one, okay, here we are written. इसका यहाँ लिखा हुआ था यार. I have taken this one, that's why I have changed it. RK channel, just give me 15 minutes because after this topic, we are going to start the setup time and hold time. In the setup time and hold time, in the 15 minutes, you guys, if you'll watch for the 15 minutes, you are able to solve the question, right? Each and every question, don't worry. Right now, how we are going to do it? So 0 1 2 4 5 6. So we can say that here the DA equal to QA QB bar X plus QB X bar. In the same manner, if you want to write for the DB, how we are going to write for the DB? 1 2 3 4 5 6 7. 1 quad, and that is called X only. So dB equal to x only. And y already we know that y equal to, if you want to write, y is only one, qa qb bar x, y equal to qa qb bar x. This is called y. We have designed it very simple. We are able to design it, right? How? Look at here. Two flip-flop I am writing, that is called DA, QA bar, DB, QB bar. Both should be connected to the same clock. Both should be connected to the same clock. Now, how we are going to find out the next one, everyone? If you want to write the DA is called QA QB bar x, QA QB bar x, x QA QB bar. QB bar. Next one is called QB x bar, QB x bar. We have designed the DA, and DB equal to nothing, it is just a x only. DB equal to x only. So we have to take the x value, this one. And y is called nothing, it is just a this output. This is called y. We have designed it because here you are getting a QA QB bar x. This one is called y. So we have designed it very simple. We have designed it very simple, right? Everyone understood? Write down yes or no. Any milli cycle you can design in this manner, guys, right? Okay. Okay. Now can anybody give me the answer of this question? This is also called 101 detector, right? Can anybody, it is visible to you, this question? Everyone, this question is visible to you? Give me the answer of this question quickly. At least you can comment it is visible to you, or should I write? चलिए मैं लिख ही देता हूँ. 0 0 in 0 out 0 in 1 out 0. I think now it's visible to you, everyone. And make it like 200, guys. Century तो बनती है बेटा, double century. 198 like is there, make it 200 at least. Yes, everyone try to understand. This is called nothing, it is just a 101. You can apply. From here we have to apply it. Already given in the problem. If you'll apply the input 1, what should be the output you will get? Everyone, output I am writing. If you'll apply the input 1, you will goes to this particular place, output is 0. And you will get to S1. Now if you'll apply the 0, you will go to this place and output is 0. Now again if you'll apply the 1, you will go to this place and output is going to be 1. Now you are at S3 state. You will at S3 state. Now 0 is applied. You are at S3 state, 0 is applied. You will move into this, output is 0. Now again the 1 is applied. You will move into the next step, output is 1. Now again you are at S3 state. 1 is there. If you'll apply the 1, you will move into the S1 and output is 0. Now again if you'll apply the 0, you will go to the S2 and output is 0. If you'll apply the 1, again your output is 1. Right, okay. If you'll apply the 0, again you will go to the S2, output is 0. Again 0 is there, we have to break it, we have to move into the S0, the output is 0. Again you will apply the 1, you will reach to the S1 and the output is 0. If you'll apply the 0, 1 na, 1 ke baad fir 1, 0. Again you have to apply the 1, 0 and 1. This one you will get. How many times the output is going to be high? Output is going to be high 1, 2, 3, 4. 4 times output is high. So yes, definitely the correct answer of this question is nothing, it is just a 4. Even you can also think this is a 101 overlap detector with overlapping. 101, 1 times output is high. Overlapping. So 101, second time output is high. Third time output is high. Fourth time output is high. This one. Hi, without overlapping is there, but this sequence is overlapping. So answer is 4. Now everyone, suppose this is the question is given. This one is the question is given and I just want to ask कि obtain the reduced state table and reduced state diagram for the sequential machine whose state is like this. A, B, C, D, E, F, G. This one is the value given, everyone. बहुत ही बढ़िया. Now everyone just give me the answer of this question, guys. देखो how we'll do it. Whenever you want to solve this question, you have to make the table, guys. Okay, how we are going to do it? Everyone try to understand. I'm writing this is called present state, this one is called next state, and this is called output. This is called output. How we are going to do it? Present state is A, B, C, D, E, F, G. How we are going to reduce the state, right? Okay. The input for x equal to 0, input 0, and for x equal to 1. For x equal to 0, for the x equal to 1. If you are at A state, everyone try to understand. If you are at A state, and if the input is 0 is basically given, you have to move to the C state. And output is going to be 0. And if you are at A state, and if the 1 is given, you have to move into the B state and output is 1. This we have written, right? You are at B state, and now input 0 is given, you have to go into the D state. Output is 0. And if you are B state, input is 1 is given, you have to move into the C state, and output is again 0. Everyone understanding how we are going to write it? You are at C state, this one is C state. If 0 is applied, you have to move into the G state. Output is 0. You are at C state, 1 is basically applied, you have to move into the D state, output is 1. Now if you are at D state, where is D? This one. If 0 is applied, you have to move into the E state. E state, output is 0. Output is 1. Sorry, output is 1. You are at D state, input is 1 is given, you have to move into the F state, and output is 0. और एक बार बोल तो दो, are you getting my point or not, everyone? Quickly. If you are at E state, everyone, E state. Now if the 0 is basically applied, you have to move into the A. Output is 1. And if 1 is applied, you have to move into the F. Output is 0. Now you are at F state. Now you are at F state. If the input is 0 is basically given, you have to move to the G. Output is 1. You are at F state, input is 1 is basically given, you have to maintain the F, and the output is 0. Now you are at G state. This one is G. If 0 is given, you have to move into the A state. Output is 0. Output is 1, sorry. And if you are at A state, sorry, G state, and input is 1 is basically given, you have to move into the F, and output is 0. We have designed it, right? We have designed it very simply. अब कुछ हो गया होगा तो चेक कर लेना बेटा D से. 0. ठीक है. Now everyone try to understand. Kaja says, sir, at A state, x equal to 0, at x equal to 0, you have to move into the C state. X equal to 0 is there. You have to move into the C state and output is 1. Oh, output is 1. Oh. And if you are at move, yes, output is 1. Yes, correct. Thank you, Kaja. Absolutely. Now everyone try to understand. If you look at this table, guys, you can observe the one thing, right? देखो, if you'll observe E and G, you will feel both are basically moving into the same state, right? So अगर दोनों ही एक ही काम कर रहा है, E and G state both are basically doing the same thing. So why should we use G? Instead of G, we are using the E. Instead of G, G is not required. So instead of G, we can use the E only. So whatever the G is there, we are using the E. G we can replace by G, we are suppressing it, right? Now, देखो, if you follow the C and everyone, C and D also you can follow. नहीं sir, F and D if you'll follow again. This is also EF10. This is also EF10. So you can feel E and F, you can say that D and F is also following the same state. So F and G is the redundant state here. Here you can feel. Right? F or G is the redundant state you can feel. Right? So we can replace the F with what? Or we can say that replace the F with D only. F with D only. So F with D only. Right? F with D only. Now we are going to state it. We are going to design it. How? So now state will become, अगला state एक मैं बनाता हूँ. A, B, C, D E only there. A, B, C, D, E is there. F and G is not there. A, B, C, D, E is there. So you can feel the next state, reduced state diagram is like this. Now you can feel everyone. This is called present state. This is called next state. And this is called your output. Now if you want to draw it, this is for x equal to 0, x equal to 1. X equal to 0, x equal to 1. Now if you want to design it, it's very simple now. A, B, C, D, E. अरे इसको तो लिखना ही नहीं था, no issues. E is only there. Now if x equal to A2, now you can feel A के लिए तो कोई चेंज C, B, C and B 1 1. Now B2, if you want to discuss D to C 0 1, DC 0 1, DC 0 1. Now C ED 0 1, ED 0 1. Now for the D, if you want to write ED 1 0, ED, अरे यहाँ तो फिर से ED हो गया. This is also called ED. This is also ED. So why should we use the D? प्रीति देखो, इफ यू वॉन्ट टू फॉलो दिस पर्टिकुलर ग्राफ ना, ट्राई टू अंडरस्टैंड मैं क्या बोलना चाह रहा हूं. क्यों पूछा वाई एफ इज नॉट देयर. एफ एंड डी यू कैन फील E to F and this is also going E to F. Both are basically going E to F and the state is basically same. So F, instead of F we can use the D only. Instead of F we can use the D only. Output different. How output is different? Same output na? 1 0 and here also 1 0. Here the output is different, so we cannot change it. Correct. E to D 0 1 and 1 0. We are not going to change it. 1 0. Output different, so we have to write. Yes, Naseem, absolutely correct. Now for the E, if you want to write, हमने E पे क्या लिखा था? D already we have written. Yes. E now we are writing. A to D 1 0. A to D 1 0. And now if you want to make the state, guys, very simple. Now we are able to make the state also. The next reduced state will be like this. Okay. Now if you apply A and input 0 is there, we have to move into the C, or 1 is there, then we have to move into the B. So 1 output 1, 0 output 1, 0, so it will move into the C, output is 1. For 1 it will move to the B, output 1. Yes, correct. Sir, B state 0 0 but written as 0 1. कहाँ लिख दिया है जया? This is absolutely correct. B state we are writing ना, from B to, if you want to move into the B से पूछ रहे हो ना, everything is fine. B state is, oh, 0 0 is there na. Okay, I have written into here 0 0. Okay, sorry sir. This is the printing mistake, you can say that. Because यहाँ तक तो कोई change ही नहीं हुआ था ना. Okay. Now, if you want to write you are at B state. Now, if you apply x equal to 0, you have to move into D. And output is 0. If you apply 1, you have to move into the C. Output is 0. Now you are at D state, C state, sorry, yes, C state. X equal to 0, E state. 0, E state, and output is 0. D state, output is 1. 1 per 1. D state. 1 to 1. ठीक है. Now you are at D state. E 0 पे E जाएगा 1, and 1 if you apply, then you have to move into the D only. 0. Now you are at E state. If 0 is given, you have to move into the A state. And now if you apply the D, we have to move into the D. E से D, output 0. This one, we have designed the reduced state. Vignesh, actually I am explaining, that's why it will take more time. Otherwise, if you do the practice, not 2 or 3 question, it's a very simple question, and there will be no trick you can feel. Either by we have solved here only. So Vignesh, at least you have to observe that. At least you have to observe the table, then only you can reduce it now. Everyone understood or not? Write down yes or no. If you understood it, one question I am giving you as a homework. Everyone, just take this question as a homework. This is 0. This is 0 1. This is 0 1. This is 0 0. 1 1. 1 0. 1 1. 0 0. A, B, C, and D. You have to find out the reduced state, everyone, for this question. Yeah, even the people are not commenting. I am asking, right? कि बता दो भाई, बता दो. कोई बोलता ही नहीं, कुछ समझ में आ रहा है कि नहीं आ रहा. 70 बच्चे बैठे हुए, कमेंट ऐसा आ रहा है जैसे मरे से हो. Now everyone, there will be the one thing more, setup time and hold time is basically remaining. But I am giving you 2 questions as a homework, right? This is the question I am giving you as a homework. You have to write the answer of this question to the comment box of this video. सबको लिखना बेटा. And whenever all the people will write the answer into the comment box now, then only I will take the setup time and hold time topic. Then only I will take the setup time and hold time topic, right? This is also homework question, right? You have to find out which state is basically we can reduce. अब देखो, A, B, C, D, E, F, G is given. You can feel F to A, F to A, both are basically same. ये तो वही वाला क्वेश्चन हो गया शायद. No issues, right? Okay. Now let me discuss about the what said. देखो यार, for the setup time and hold time, everyone, then I'm just giving you the 2 choice. Because if you want on very much of detail regarding to the setup time and hold time, around 1.5 hours basically required. But if you write the directly formula, if you required, then I'm just giving you here only the formula. But if you require the command over the setup time and hold time, contamination delay, then it will take 1.5 hours. And if you if you'll allow me, then I will take the session into the Hindi channel, right? Maybe tomorrow or day after tomorrow, most probably tomorrow or day after tomorrow, you can think, right? But in very much of detail, around 10 question on the setup time and hold time we'll discuss, right? Setup time and hold time we'll discuss the 10 question, more than 10 question of setup time, hold time. What should be the setup violation? What should be the hold violation? Everything in the very much of detail we'll discuss, right? Otherwise, I will give you, if you want to discuss, I have to discuss only the formula. Because we have already 2.5 hours, right? अरे कुछ तो बोलो ना, जिंदा हो everyone. Can you respond for it? So guys, setup time and hold time, because देखो, in the last year also I thought that question will question came, but they are not asked any question regarding to the setup time and hold time into the last year. But in this year we can expect definitely the question based on the setup and hold time. So guys, this topic already I have taken the PD. देखो मैं लेके आया था सारा चीज, right? कि I have to take it here, setup time, what should be the meaning, how it is going to be happen. So everything I have taken, how the formula is basically derived, what should be the data path, what should be the clock path. But due to the shortage of the time, give the formula and explain detail extra class. Rahul, I will give you the formula na, then nobody will take the interest on it. So Rahul, because formula de bhi dunga na, how the formula is derived, that is important. So I will take the session dedicated for the setup time and hold time. So the people having a doubt on it, they will get the clarity on it, and you can say that in detailed version I will take. What should be the violation is happened, what should be the meaning of skew, how the skew is introduced in there. Yes, Vignesh, I will take into the English, don't worry, right? Okay guys, so thank you very much, all the very best. And the PDF of this particular class, I will send it into the Telegram channel just after the class, right? So guys, thank you. And one thing more, whenever I will send the link of that particular, you can say that video into the Telegram channel, I must attend the session, because setup time and hold time will happen only when the more than 100 people will come live, right? Before clock, yes, Hari, but Hari, in very much of detail we'll discuss, not only basic, so that whenever you do the MTech na, into the VLSI, that will also help you. Yes, Tushara, I will take into English, don't worry. हाँ वही अलन, चलो कोई दिक्कत नहीं. So yes, only the setup time and hold time, and more question we'll discuss, right? So guys, thank you very much, all the very best, take care, bye bye, and share among all of your friends. Thank you everyone, take care. And one thing more, please conscious, right, take care of your health guys, because health will be in the first priority. तबीयत खराब हो गई तो at this particular moment we cannot you can say that tolerate even the 2 days break, right? So you have to manage your health also, right? Thank you everyone, take care, bye bye. Thank you Preeti, thank you. No password, this will the Vignesh available for the everyone.